Dinosaurs, some of the most captivating creatures to ever walk the earth, reigned during a time that feels like a dreamscape, a world completely different from the one we know today. Their story is etched into the rocks and fossils, offering us glimpses of their majestic and sometimes mysterious lives. Tonight, as you drift into slumber, let your mind wander through the prehistoric landscapes where dinosaurs roamed, basking in their extraordinary existence. Imagine lush forests teeming with plants long extinct, towering ferns, and trees like cycads and ginkgos that once thrived during the Mesozoic era. Dinosaurs lived in this verdant world, one alive with the hum of insects and the calls of early birds. The earth then was warmer, the continents were still shifting, and the environment brimmed with possibilities, shaping the destiny of these ancient creatures. Dinosaurs were remarkably diverse, ranging in size from the chicken-sized Compsognathus to the enormous Argentinosaurus, which stretched nearly 100 feet in length. Their shapes and forms were equally astonishing: bipedal predators with razor-sharp teeth, massive quadrupeds with sweeping tails, and even feathered dinosaurs whose plumage hinted at connections to modern birds. Each species carved its niche in a prehistoric ecosystem that was as intricate and interwoven as nature is today. One of the most famous dinosaurs, Tyrannosaurus rex, was both feared and admired. With a bite force estimated at over 12,000 pounds, this apex predator was built to crush bones and devour prey with incredible efficiency. Yet, scientists have discovered surprising details about T. rex. For instance, it likely had a keen sense of smell, making it an excellent tracker, and recent studies suggest that its short, seemingly useless arms may have been adapted for powerful grappling during close combat. But not all dinosaurs were fearsome. Consider the gentle Diplodocus, with its long neck that stretched to reach high foliage. This dinosaur could strip entire branches with its peg-like teeth, but swallowed food without chewing. Then there's Ankylosaurus, a living tank with a body covered in bony armor and a tail club strong enough to shatter bones. These creatures weren't just animals. They were evolutionary marvels, perfectly adapted to their environments. Beyond their physical traits, dinosaurs' survival strategies were mind-blowing. Many laid eggs, often in communal nests, and some species are believed to have cared for their young. Fossilized nests and embryos give us a window into their life cycles. Imagine a mother Maiasaura, a good mother lizard, tending to her nest, feeding her hatchlings with carefully selected plants. Such behaviors hint at the complex social structures some dinosaurs might have had. Dinosaurs also lived through dynamic earth changes. They adapted to fluctuating climates, rising seas, and volcanic activity that reshaped continents. Their resilience is awe-inspiring. Fossil evidence shows that dinosaurs inhabited every continent, from the icy polar regions to the tropical equator, thriving in environments that would seem inhospitable today. The connection between dinosaurs and modern birds is a revelation that bridges prehistoric times to the present. Fossil evidence of feathered dinosaurs like Archaeopteryx shows the gradual evolution of flight. These creatures, once thought of as mere reptiles, reveal an astonishing link to the birds chirping outside your window. Imagine the vibrant colors of a Microraptor's feathers glinting under the Mesozoic sun, an early precursor to the iridescent plumage of a hummingbird. Dinosaurs were also far from the cold-blooded reptiles they were once imagined to be. Many species were likely warm-blooded, their metabolisms fueling active lifestyles. Studies of their bone structures suggest rapid growth rates, especially in juveniles, hinting at energy-intensive lives. Some even migrated in herds, covering vast distances in search of food or more favorable climates. The Earth's prehistoric sky was a sight to behold. Massive flying reptiles like Quetzalcoatlus, with wingspans rivaling small airplanes, dominated the air. These creatures weren't dinosaurs but shared their era, ruling a domain that complemented the terrestrial reign of their ground-dwelling cousins. Watching a Quetzalcoatlus glide effortlessly would have been a humbling reminder of nature's boundless ingenuity. As the Mesozoic era progressed, the diversity of dinosaurs continued to expand. Carnivores evolved sharper claws and deadlier hunting techniques, while herbivores developed defenses like spiked tails, armored plates, and even herding behaviors to protect themselves. The balance of predator and prey created a dynamic ecosystem where survival required constant adaptation. Their extinction, brought about by a catastrophic asteroid impact 66 million years ago, marked the end of their dominion but not their story. The resulting environmental changes, fires, tsunamis, and a nuclear winter wiped out about 75% of life on Earth. Yet, the small, bird-like dinosaurs that survived adapted and evolved, ensuring that the legacy of dinosaurs continues to this day. Fossils, the echoes of these ancient beings, provide us with an ever-evolving story. From dinosaur tracks frozen in stone to exquisitely preserved skeletons revealing musculature and behavior, these remnants are windows into a time long past. Each discovery adds another layer to the intricate tapestry of their existence. As you drift deeper into sleep, let your imagination wander to a world where dinosaurs roam freely. Picture herds of triceratops grazing on ferns, their frills gleaming in the sunlight, while a pair of velociraptors stalks silently through the underbrush. Feel the rumble of a distant brachiosaurus, its footsteps echoing like thunder. Their world may be gone, but their story remains, etched in stone and preserved in our collective wonder. Dinosaurs are more than ancient creatures. They are a testament to the power of life, evolution, and survival against unimaginable odds. Imagine the lush wetlands of the late Jurassic period, where herds of Stegosaurus roamed under the watchful eyes of predators like Allosaurus. The air was thick with humidity, and the distant calls of pterosaurs filled the skies. Each step of a Stegosaurus was deliberate, its spiked tail, a weapon known as a thagomizer, swaying rhythmically as a deterrent to any would-be attacker. Its back was adorned with large, alternating plates, their exact purpose still debated among scientists. Were they for thermoregulation, display, or intimidation? Regardless, they made the Stegosaurus one of the most iconic dinosaurs of its time. Nearby, rivers teeming with life wound through the landscape, their waters reflecting the sunlight like liquid gold. Crocodilian ancestors lurked beneath the surface, waiting patiently for an opportunity to snap at unwary prey. These rivers were vital lifelines, supporting an ecosystem that buzzed with activity. Fish and early amphibians thrived, providing a crucial food source for both dinosaurs and their contemporaries. The oceans of the Mesozoic era were no less mesmerizing. Vast and mysterious, they were home to marine reptiles like Mosasaurus, Plesiosaurus, and Ichthyosaurus. Imagine a Mosasaurus, its immense body slicing through the water with precision, hunting prey with a force unmatched in its aquatic domain. These creatures weren't dinosaurs, but were equally impressive rulers of their environment. Fossil evidence reveals their streamlined bodies and sharp teeth, perfectly adapted for a life of relentless predation. On land, the late Cretaceous brought new giants into the spotlight. The Triceratops, with its 3 prominent horns and a massive frill, was both a symbol of defense and an enigma. Its horns could fend off predators like Tyrannosaurus rex, but its frill might have been used for courtship displays or communication within its herd. Fossilized skulls show evidence of healed wounds, hinting at battles fought and won, both against predators and rivals. In the same period, the Parasaurolophus, a herbivore with a striking, elongated crest, wandered through forests and plains. This crest, a hollow structure connected to its nasal passages, likely allowed it to produce resonant sounds. Imagine a Parasaurolophus calling out across a valley, its mournful yet majestic notes echoing for miles. These calls might have been used to communicate with its herd, warn of danger, or establish territory. The behavioral complexity of dinosaurs often mirrors that of modern animals. Some species formed herds, providing mutual protection and increasing their chances of survival. Others, like Velociraptor, were likely pack hunters, coordinating their efforts to take down larger prey. Fossilized evidence, such as trackways and nesting sites, suggests that social behaviors were integral to the lives of many dinosaurs. Speaking of nests, the discovery of fossilized dinosaur eggs has opened a window into their reproductive strategies. The nests of Protoceratops, small ceratopsians, were carefully constructed, with eggs arranged in circular patterns. This meticulous arrangement hints at parental care, suggesting that these creatures didn't Triceratops guarding its nest against predators, its instincts driven by the need to ensure the survival of the next generation. The sensory abilities of dinosaurs were also extraordinary. Research into the fossilized skulls of Tyrannosaurus rex reveals large olfactory bulbs, indicating an exceptional sense of smell. This predator could likely detect prey from miles away, an invaluable skill in the dense forests of the late Cretaceous. Meanwhile, the keen eyesight of raptors like Deinonychus gave them an edge in stalking and ambushing prey, their stereoscopic vision allowing for precise depth perception. Dinosaurs also communicated in ways that would have filled their environments with sound and activity. Crests, horns, and frills were not merely ornamental but served as visual cues and interactions. Vocalizations, too, played a role. While we can only hypothesize about the sounds dinosaurs made, comparisons to modern birds and reptiles suggest a range of calls, from low rumbles to high-pitched shrieks. The fossil record continues to reveal astonishing details about their physiology. For instance, evidence of feathers in species like Sinosauropteryx and Microraptor has redefined our understanding of dinosaurs as exclusively scaly. Feathers served various purposes, from insulation to display, and even the possibility of gliding or flight in smaller species. The vibrant colors preserved in some fossilized feathers suggest a world as vivid and colorful as our own. The Mesozoic world wasn't static, it was ever-changing, shaped by tectonic movements and climatic shifts. The breakup of the supercontinent Pangaea during this era created new coastlines, mountain ranges, and ecosystems. These changes forced dinosaurs to adapt, driving evolution and diversification. Herbivores developed specialized teeth to handle tough vegetation, while carnivores became faster and more agile to catch increasingly elusive prey. As the sun set on the age of dinosaurs, the Earth was a planet in flux. The asteroid impact that marked the end of the Cretaceous period brought abrupt and catastrophic changes. The immediate aftermath, fires, tsunamis, and a nuclear winter caused by dust and debris blocking sunlight, decimated plant life and disrupted the food chain. Yet, even in the face of such devastation, life persisted. The small, bird-like dinosaurs that survived adapted to new niches, eventually giving rise to the avian species we see today. Each fossil unearthed is a fragment of this incredible story. Dinosaur footprints frozen in time, skeletons locked in combat, and even fossilized droppings provide clues about their diets, behaviors, and environments. These remnants remind us of the resilience and adaptability of life on Earth, offering lessons for our own existence. As you lie in bed, let the wonders of the prehistoric world lull you to sleep. Picture the silhouettes of dinosaurs moving across a twilight landscape, their forms blending with the ancient forests. Imagine the distant calls of a Parasaurolophus, the rustle of ferns as a Diplodocus grazes, and the rhythmic beat of a pteranodon's wings overhead. Their world, though long gone, continues to captivate our imagination, a timeless testament to the mysteries and marvels of life on Earth. Dinosaurs weren't the only stars of their prehistoric world. Their ecosystems included a vast array of flora and fauna, each playing a crucial role in maintaining the balance of their environments. Imagine a dense forest of conifers, cycads, and ginkgo trees. These plants, ancient ancestors of today's flora, provided shelter and sustenance for herbivorous dinosaurs. Ferns blanketed the forest floors, their delicate fronds swaying in the humid breeze. These plants didn't just feed herbivores like Iguanodon and Stegosaurus. They also shaped the very fabric of life by contributing to the planet's oxygen levels. Prehistoric insects buzzed through these primeval forests, some of them astonishingly large compared to their modern counterparts. Dragonflies with wingspans exceeding 2 feet darted between the trees, their iridescent bodies glinting in the sunlight. Beetles and ants, precursors to today's myriad species, scurried about, recycling nutrients and helping the ecosystem thrive. These small but essential creatures supported a web of life that reached from the ground to the towering canopy. In the vast open plains, dinosaurs like Hadrosaurus roamed in herds. These duck-billed dinosaurs were remarkable for their specialized teeth, designed to grind tough plant material. Herd behavior not only provided safety in numbers, but also ensured the survival of their species. Fossilized footprints of Hadrosaurus show pathways carved through ancient landscapes, evidence of their migratory patterns as they moved in search of food and water. Meanwhile, the skies above were alive with the flapping of wings. Pterosaurs, the flying reptiles of the Mesozoic, soared effortlessly, masters of an aerial realm. The largest of them, Quetzalcoatlus, had a wingspan rivaling that of a small aircraft. Its hollow bones and lightweight frame allowed it to glide for long distances, searching for prey or scavenging along coastlines. Smaller pterosaurs, like Pterodactylus, darted through the air, their sharp eyes scanning for fish or insects. Amidst the rivers and lakes, dinosaurs ventured for water and sustenance. Spinosaurus, one of the most fascinating and enigmatic of dinosaurs, is believed to have been semi-aquatic. With a long, crocodile-like snout and a massive sail on its back, this predator was perfectly adapted for hunting fish in shallow waters. Fossils show where patterns on its teeth consistent with a diet of aquatic prey, revealing how some dinosaurs thrived in this unique ecological niche. Volcanoes punctuated the landscapes of the Mesozoic, their eruptions shaping the terrain and influencing the climate. Lava flows created new landforms, while the ash clouds enriched the soil, promoting the growth of lush vegetation. These volcanic activities also played a role in the fossilization process. When dinosaurs perished in volcanic eruptions or other natural disasters, their remains were sometimes buried quickly by ash or sediment, preserving them for millions of years. As dinosaurs evolved, their physiology became increasingly specialized. Consider the incredible neck of Brachiosaurus, which could stretch upward to browse on the highest tree branches. The structure of its vertebrae, combined with an efficient circulatory system, allowed blood to reach its brain despite the great height. Similarly, Therizinosaurus, with its long, scythe-like claws, defied traditional expectations of dinosaur anatomy. These claws, which measured up to 3 feet, were likely used for pulling down branches or for defense, making this herbivore both unique and formidable. Dinosaurs also faced challenges from within their own ecosystems. Predators and prey engaged in an evolutionary arms race, with each adapting to outwit the other. Ankylosaurs, like Ankylosaurus, developed thick, bony armor and tail clubs as a countermeasure against predators like Tyrannosaurus rex. These adaptations not only ensured their survival but also influenced the behavior and hunting strategies of their predators, driving an ongoing cycle of evolutionary innovation. The Great Extinction at the end of the Cretaceous period was a pivotal moment in Earth's history. The asteroid impact that struck the Yucatan Peninsula unleashed energy equivalent to billions of nuclear bombs, creating a crater over 90 miles wide. The immediate aftermath saw firestorms, tsunamis, and a choking blanket of dust and debris that blocked sunlight for months, plunging the planet into a dramatic impact winter. Temperatures dropped, plant life withered, and ecosystems collapsed, unable to support the massive dinosaurs that had once ruled the Earth. But life, resilient as ever, persisted. Smaller creatures, including mammals and bird-like dinosaurs, adapted to the harsh new conditions. These survivors were the ancestors of modern birds and mammals, carrying the legacy of the dinosaurs into a new era. The extinction of the non-avian dinosaurs marked the end of an age, but it also set the stage for the rise of new life forms, including humans. The study of dinosaurs has come a long way since the first fossils were discovered. In the early days, they were thought to be sluggish, cold-blooded reptiles. Today, thanks to advancements in technology and new discoveries, we know they were dynamic, complex creatures. Fossilized footprints reveal how they moved, while CT scans of skulls provide insights into their brains and senses. Even fossilized soft tissues, like skin and feathers, offer glimpses of their textures and colors. One of the most exciting developments in paleontology is the study of dinosaur behavior. Fossilized nests show how some species cared for their young, suggesting nurturing instincts similar to modern birds. Evidence of pack hunting in species like Deinonychus indicates social cooperation. These behaviors bring dinosaurs to life in ways that go beyond mere skeletons, painting a vivid picture of their lives. Modern technology has also allowed scientists to analyze the chemistry of fossils, uncovering details about diet and environment. Isotopic analysis can determine what dinosaurs ate and where they lived, while microscopic studies of bone structure reveal their growth rates and lifespans. These techniques continue to uncover new layers of understanding, making the prehistoric world feel closer than ever. As you drift deeper into relaxation, imagine the vibrant hues of a feathered velociraptor chasing its prey across a sunlit clearing. Picture the herds of triceratops moving slowly through a misty plain, their horns silhouetted against the dawn. Envision the sweeping expanse of prehistoric oceans, where mosasaurus prowled and schools of ancient fish darted in synchronized movements. These visions remind us of the boundless diversity of life that once graced our planet. The story of dinosaurs is not merely one of extinction, but of adaptation, innovation, and survival. From their humble beginnings as small, lizard-like creatures to their dominance as the largest animals to ever walk the earth, dinosaurs embody the power of evolution. Their fossils, scattered across the globe, are whispers of a time when the world was young and full of wonder. Let the memory of these prehistoric giants guide you into restful sleep, their legacy a testament to the beauty and resilience of life on Earth. As the Mesozoic era progressed, the diversity of dinosaurs expanded into every imaginable ecological niche. Some took to the skies, evolving into the first avian species, while others became specialized for aquatic environments or adapted to dominate vast terrestrial landscapes. Their evolutionary story is one of constant adaptation and innovation, shaped by the forces of nature over millions of years. The transition of some dinosaurs into birds is one of the most remarkable chapters in evolutionary history. Fossils of Archaeopteryx, discovered in Germany, reveal a fascinating blend of traits, feathers, and a wishbone typical of modern birds, but also teeth, claws, and a long bony tail characteristic of reptiles. This missing link offers a glimpse into the gradual transformation of dinosaurs into creatures capable of powered flight. Imagine the delicate flapping of Archaeopteryx wings as it glided from branch to branch, evading predators and hunting for small prey. Feathers themselves, long associated solely with flight, had a variety of functions among dinosaurs. In species like Sinosauropteryx, feathers likely served as insulation, helping these small, agile hunters maintain their body temperature. In others, such as Caudipteryx, brightly colored feathers may have played a role in attracting mates or intimidating rivals. These vibrant displays, shimmering under the Mesozoic sun, would have added a layer of visual drama to the prehistoric world. Dinosaurs also varied widely in their methods of locomotion. The swift and nimble velociraptor relied on its sickle-shaped claws for gripping and slicing, making it a fearsome predator. Fossilized trackways of Velociraptor suggest it moved with a dancer's precision, its movements calculated and deadly. In contrast, the massive titanosaurs, some of the largest land animals to ever exist, lumbered across ancient plains with slow, deliberate steps. Their immense size was their greatest defense, as few predators would dare challenge such giants. The social lives of dinosaurs were equally complex. Herding behaviors are evident in species like Edmontosaurus, whose fossilized tracks often appear in parallel patterns, suggesting group movement. Such herds would have offered protection from predators and increased the chances of locating food and water. Meanwhile, the discovery of nesting sites, such as those of Maiasaura, provides evidence of parental care. These good mother lizards tended their young, nurturing them until they were strong enough to fend for themselves. Predatory dinosaurs, too, displayed remarkable behavioral adaptations. Allosaurus, one of the dominant predators of the Jurassic period, had a unique hunting strategy. Its serrated teeth were designed to inflict deep wounds, and studies of its skull suggest it used its upper jaw like a hatchet, delivering powerful slashing blows. This technique allowed it to take down prey much larger than itself, securing its place at the top of the food chain. In the late Cretaceous, the Earth was home to some of the most iconic dinosaurs, including Tyrannosaurus rex. Despite its fearsome reputation, T. rex was more than just a predator. It was an opportunist, scavenging when necessary and using its keen sense of smell to locate carrion from miles away. Recent studies of T. rex fossils have revealed evidence of healing bite marks, suggesting that even apex predators engaged in fierce battles with rivals. The interplay between predator and prey drove much of dinosaur evolution. Herbivores developed elaborate defenses to protect themselves, from the thick armor of Ankylosaurus to the whip-like tails of Diplodocus. These adaptations not only helped them survive, but also spurred predators to become faster, stronger, and smarter, fueling an evolutionary arms race that shaped the diversity of dinosaur life. The landscapes of the Mesozoic were as varied as the dinosaurs themselves. Vast deserts, lush rainforests, and expansive wetlands provided habitats for a wide array of species. In the arid regions of what is now North America, the horned Triceratops thrived, its three-pronged defense mechanism an iconic symbol of resilience. Meanwhile, in the coastal areas, dinosaurs like Spinosaurus adapted to semi-aquatic lifestyles, their crocodile-like jaws perfect for catching fish. Beneath the surface of ancient seas, marine reptiles reigned supreme. Ichthyosaurus, with its sleek, dolphin-like body, was a swift and agile predator, while Plesiosaurus, with its long neck, could dart its head into schools of fish. These creatures, though not technically dinosaurs, shared the stage of the Mesozoic and contributed to the richness of prehistoric biodiversity. The end of the Mesozoic era came abruptly with the asteroid impact that marked the Cretaceous-Paleogene (KPG) extinction event. The asteroid, estimated to be 6 miles wide, struck Earth with unimaginable force, creating the Chicxulub crater in what is now Mexico. The immediate effects were catastrophic: shockwaves, massive wildfires, and a cloud of debris that plunged the planet into darkness. Photosynthesis halted, temperatures plummeted, and ecosystems collapsed. This mass extinction wiped out about 75% of Earth's species, including all non-avian dinosaurs. However, the resilience of life ensured that not all was lost. Mammals, once small and inconspicuous, began to diversify, filling niches left vacant by the dinosaurs. Birds, the avian descendants of theropod dinosaurs, continued to evolve, their songs and flights a living echo of the prehistoric past. Fossils of dinosaurs remain as silent witnesses to their reign. The intricate details preserved in fossilized bones, footprints, and even soft tissues allow scientists to piece together their stories. In some cases, fossils capture moments frozen in time. A dinosaur locked in combat with a predator, a herd crossing a muddy plain, or a nest filled with eggs. These snapshots offer glimpses of a world that existed millions of years ago, a world as vibrant and complex as our own. Advances in technology have transformed paleontology, enabling researchers to study dinosaurs in ways previously unimaginable. CT scans reveal the internal structures of fossils, providing insights into brain size, sensory capabilities, and growth patterns. Isotopic analysis uncovers details about diet and habitat, while high-resolution imaging captures microscopic features, such as the arrangement of blood vessels in fossilized bones. One of the most fascinating areas of study is the coloration of dinosaurs. Pigment structures preserved in fossilized feathers have allowed scientists to infer the colors and patterns of some species. Anchiornis, for example, likely sported black and white plumage with hints of orange, creating a striking appearance. These discoveries bring dinosaurs to life in vivid detail, challenging the traditional view of them as drab, scaly reptiles. As you relax into the rhythm of prehistoric time, imagine the landscapes of the Mesozoic era teeming with life. Picture a stegosaurus ambling through a forest, its plates catching the light of the setting sun. Envision a flock of feathered raptors darting through the underbrush, their calls echoing in the twilight. The world of dinosaurs was one of endless wonder, a testament to the creativity and resilience of life. The landscapes of the Mesozoic era weren't just stages for dinosaur dramas. They were dynamic arenas where Earth's forces collided and reshaped life itself. Tectonic shifts during this time played a crucial role in determining the habitats dinosaurs would occupy. The breakup of the supercontinent Pangaea, beginning in the Jurassic period, set the stage for new ecosystems. As the land masses drifted apart, they created vast inland seas, mountain ranges, and coastlines. These geological changes not only influence climate patterns, but also contributed to the incredible diversity of dinosaur species. In these evolving landscapes, dinosaurs developed remarkable adaptations. Take the sauropods, for example, towering, long-necked giants like Apatosaurus and Argentinosaurus. Their immense size allowed them to reach food sources unavailable to smaller herbivores, giving them a competitive advantage. To support their massive frames, sauropods had uniquely structured bones, filled with air sacs to reduce weight while maintaining strength. Their long necks were marvels of engineering, enabling them to graze over vast areas without moving their enormous bodies. Contrast this with the small, nimble theropods like Troodon. Known for its relatively large brain, Troodon is often cited as one of the most intelligent dinosaurs. Its keen eyesight and agility made it an adept hunter, while its grasping hands allowed it to manipulate objects. Such intelligence raises intriguing questions about the social behaviors and problem-solving abilities of some dinosaur species. Even within the realm of herbivores, diversity abounded. Ornithopods like Iguanodon were equipped with specialized dentition for grinding tough vegetation. Fossil evidence suggests they lived in herds, offering protection from predators and ensuring access to food in a rapidly changing environment. These herbivores were often targets for larger predators like Allosaurus, which hunted in open plains and forested areas. Speaking of predators, the fossilized remains of Allosaurus reveal fascinating details about its hunting strategies. Its skull was designed to withstand the stresses of tearing into prey, with strong muscles and sharp teeth capable of inflicting devastating wounds. Yet, despite its fearsome appearance, evidence suggests it may have been a cooperative hunter, working with others of its kind to take down larger prey. Dinosaurs weren't the only creatures evolving during this time. The Mesozoic skies were dominated by pterosaurs, whose adaptations for flight rival those of modern birds. Some, like Dimorphodon, had relatively short wings but powerful legs, allowing them to launch into the air with precision. Others, like the enormous Quetzalcoatlus, soared effortlessly over great distances, its lightweight skeleton perfectly suited for life in the skies. Beneath the waves, marine reptiles carved out their own niches. Ichthyosaurus resembled a modern dolphin, its streamlined body built for speed. With large eyes adapted for seeing in dim underwater light, it hunted cephalopods and fish with remarkable efficiency. Meanwhile, Kronosaurus, a massive pliosaur, was a top predator in ancient seas, its powerful jaws capable of crushing even the hardest shells. The interplay of life in these varied environments created a web of interactions that echoed through time. Fossilized stomach contents and coprolites, fossilized dung, provide direct evidence of these interactions, revealing not only what dinosaurs ate, but also how they fit into their ecosystems. For example, the discovery of fish remains in the coprolites of Spinosaurus confirmed its semi-aquatic lifestyle, while plant material in Edmontosaurus fossils highlights its role as a grazer. One of the most intriguing aspects of dinosaur life is their growth and development. Fossilized bones show growth rings, similar to those in trees, which reveal how quickly a dinosaur grew and when it reached maturity. Studies of Tyrannosaurus rex suggest it experienced a growth spurt during its teenage years, gaining hundreds of pounds annually before reaching its massive adult size. This rapid growth likely required a high metabolism, further supporting the theory that many dinosaurs were warm-blooded. The warm-blooded nature of dinosaurs has been a topic of intense debate among scientists. Evidence from bone structures, such as the presence of haversian canals, channels that allow for the flow of blood and nutrients, suggests that many dinosaurs had metabolisms closer to those of birds and mammals than to cold-blooded reptiles. This high metabolic rate would have supported active lifestyles, enabling dinosaurs to hunt, migrate, and reproduce more effectively. Dinosaurs also left behind clues about their social behaviors. Trackways, fossilized footprints preserved in sediment, provide direct evidence of group movement. For instance, parallel tracks of Hadrosaurus indicate that these herbivores traveled in herds, while overlapping tracks of theropods suggest pack hunting. Even nesting sites offer insights into dinosaur social structures. Fossils of Maiasaura nests, for example, show that these dinosaurs returned to the same sites year after year, carefully arranging their eggs and possibly caring for their hatchlings. The discovery of fossilized embryos has further deepened our understanding of dinosaur reproduction. These delicate fossils reveal the developmental stages of dinosaurs within their eggs, providing a glimpse into their earliest moments of life. The arrangement of embryos within the eggs suggests that some species, like Protoceratops, had well-organized nesting behaviors, potentially with adults guarding the eggs until they hatched. As the age of dinosaurs unfolded, their world was constantly reshaped by geological and climatic changes. Massive volcanic eruptions, like those of the Deccan Traps in present-day India, released vast amounts of gases into the atmosphere, affecting global temperatures and weather patterns. These eruptions may have created challenging conditions for dinosaurs, forcing them to adapt or migrate to survive. The fossil record also highlights moments of catastrophe, such as the Cretaceous-Paleogene (KPG) extinction event. The asteroid impact that ended the reign of non-avian dinosaurs left behind evidence in the form of a thin layer of iridium-rich clay, found worldwide. This layer marks a moment of profound change in Earth's history, a transition from the Mesozoic era to the rise of mammals and the eventual evolution of humans. Despite their extinction, dinosaurs' legacy endures in the form of birds. Modern avian species carry the genetic and anatomical traces of their prehistoric ancestors. From the intricate structure of feathers to the hollow bones that make flight possible, these traits are a testament to the enduring power of evolution. As you drift into deeper relaxation, let your imagination soar through the Mesozoic skies alongside a pteranodon. Glide over dense forests where Brachiosaurus stretch their necks toward the canopy, and watch as a Tyrannosaurus rex prowls through the underbrush. Picture the shimmering scales of Mosasaurus slicing through ancient seas, and hear the haunting calls of Parasaurolophus echoing across prehistoric plains. The age of dinosaurs may have ended, but their story lives on, a reminder of the extraordinary possibilities of life on Earth. The evolutionary journey of dinosaurs is a story of resilience and adaptation, a testament to life's ability to thrive under ever-changing conditions. The Mesozoic era, spanning over 180 million years, saw countless species rise and fall, each contributing to the intricate web of prehistoric life. Their incredible diversity, from the smallest bird-like theropods to the largest sauropods, highlights the sheer ingenuity of evolution. Imagine the dawn of a Mesozoic morning, where the sun rises over an ancient swamp. Mist hangs heavy in the air, and the landscape is alive with sound. A herd of iguanodon grazes along the water's edge, their thumb spikes ready to fend off any predators that might approach. Nearby, a baryonyx wades through the shallows, using its long claws to snatch fish from the water. This predator's crocodile-like snout and sharp teeth make it perfectly suited for a semi-aquatic lifestyle, blurring the lines between land and water. In the forest, a group of Compsognathus, no larger than chickens, scurries across the undergrowth in search of insects. These small, agile theropods are reminders that dinosaurs came in all shapes and sizes, filling every conceivable ecological niche. Their speed and sharp senses make them adept hunters, while their small size allows them to exploit resources unavailable to larger dinosaurs. The fossil record reveals the extraordinary range of dietary strategies among dinosaurs. Herbivores like Diplodocus and Apatosaurus used their long necks to reach high branches, stripping leaves with peg-like teeth. Others, like Triceratops, were low browsers, using their powerful beaks to shear through tough vegetation. Carnivorous dinosaurs, on the other hand, developed a range of hunting adaptations. The serrated teeth of Allosaurus were perfect for slicing flesh, while the sharp claws of Velociraptor enabled it to hold onto struggling prey. Some of the most fascinating dinosaurs are those that seem to defy traditional categorizations. Take Therizinosaurus, with its enormous, scythe-like claws. Once thought to be a fearsome predator, evidence now suggests it was a herbivore, using its claws to pull down branches or strip leaves. This blend of traits highlights the complexity of dinosaur evolution and the difficulty of making assumptions based on appearance alone. Another enigma of the dinosaur world is Spinosaurus. Fossil evidence suggests it was the largest carnivorous dinosaur, even surpassing Tyrannosaurus rex in size. With a long, crocodilian snout, and a sail-like structure on its back. Spinosaurus was uniquely adapted for a semi-aquatic lifestyle. It likely hunted fish in rivers and swamps, using its strong limbs and streamlined body to maneuver through the water. This specialization sets it apart from other theropods, showcasing the incredible adaptability of dinosaurs. The skies of the Mesozoic were equally remarkable. Pterosaurs, the first vertebrates to achieve powered flight, dominated the aerial realm. While not dinosaurs themselves, these flying reptiles shared their world and contributed to the biodiversity of the era. From the small, bat-like Anurognathus to the towering Quetzalcoatlus, with a wingspan of up to 40 feet, pterosaurs were masters of the sky. Their fossils reveal lightweight skeletons and specialized wing membranes, adaptations that allowed them to exploit aerial niches. Marine reptiles ruled the oceans with equal majesty. The dolphin-like Ichthyosaurus was an agile swimmer, while Chronosaurus, a massive pliosaur, was a formidable predator. These creatures weren't dinosaurs but evolved alongside them, filling the oceans with life and competition. Fossilized stomach contents provide direct evidence of their diets, revealing interactions between marine reptiles and the creatures they hunted. Dinosaurs' dominance was not just a result of their physical adaptations, but also their ability to exploit changing environments. The breakup of Pangaea during the Jurassic and Cretaceous periods created a patchwork of isolated ecosystems, spurring speciation and diversity. Dinosaurs adapted to new climates, from the lush rainforests of the tropics to the arid deserts of what is now North America. Their ability to thrive in such varied conditions speaks to the versatility of their biology. As the Cretaceous period drew to a close, the stage was set for a dramatic finale. The asteroid impact that ended the Mesozoic era was a cataclysmic event, but it wasn't the only challenge dinosaurs faced. Volcanic activity, particularly in the Deccan Traps of India, released massive amounts of greenhouse gases, altering the climate and stressing ecosystems. Rising sea levels and shifting continents added further instability, creating a perfect storm of environmental change. The asteroid impact itself was devastating. The energy released upon collision vaporized rock and sent shockwaves through the Earth. The resulting dust and debris blocked sunlight, creating a nuclear winter that disrupted photosynthesis and collapsed food chains. Large herbivores, unable to find enough food, perished, followed by the predators that relied on them. Within a few years, the vast majority of dinosaur species were extinct. Yet, even in this time of destruction, life found a way. Small mammals, which had lived in the shadows of dinosaurs for millions of years, began to diversify. Their ability to burrow and their omnivorous diets helped them survive the harsh conditions. Birds, the direct descendants of theropod dinosaurs, also endured, their small size and flight capabilities giving them an edge in the post-impact world. The legacy of dinosaurs is carried on by these avian descendants. Modern birds exhibit many traits inherited from their dinosaur ancestors, from their hollow bones to their feathers. Even behaviors like nesting and caring for young, first seen in species like Maiasaura, persist in today's birds. Every time a bird takes flight, it carries a piece of the Mesozoic with it, a living reminder of a world long past. The study of dinosaurs continues to evolve, with new discoveries reshaping our understanding of their lives. From the vibrant colors of their feathers to the complexity of their social behaviors, dinosaurs were far more dynamic than once imagined. Advances in technology, such as 3D modeling and isotopic analysis, allow scientists to reconstruct their habitats, diets, and even their movements with unprecedented accuracy. Fossils remain our most direct link to this ancient world. Each bone, footprint, and fossilized feather is a window into the past, a piece of the puzzle that forms the story of dinosaurs. The discovery of soft tissues in some fossils has opened new avenues of research, providing insights into their physiology and even their molecular makeup. As you drift deeper into relaxation, let your mind wander through the Mesozoic landscapes where dinosaurs once roamed. Picture a stegosaurus ambling through a sunlit meadow, its plates catching the light. Envision a Quetzalcoatlus soaring high above, its shadow gliding over the terrain below. Imagine the gentle splash of a Brachiosaurus drinking from a river, its massive neck stretching toward the heavens. Though their reign has ended, the spirit of dinosaurs lives on in every fossil unearthed, every bird in the sky, and every new discovery that brings their world back to life. They are a testament to the resilience and creativity of life, a reminder of the boundless possibilities that Earth has nurtured over billions of years. Dinosaurs were not only masters of adaptation but also architects of their environments, shaping ecosystems in ways that resonate even in the modern world. Their immense size, diverse diets, and unique behaviors influence the distribution of plants, the structure of habitats, and even the cycles of nutrients within their ecosystems. These interactions paint a vivid picture of a world teeming with life, where every organism, from the smallest insect to the largest sauropod, played a role in maintaining the delicate balance of nature. Picture a late Jurassic savanna, where herds of Diplodocus wander across open plains dotted with ferns and cycads. These gentle giants act as ecosystem engineers, their grazing creating open spaces that encourage the growth of new plants. Their droppings, rich in nutrients, fertilize the soil, supporting a diverse array of plant and microbial life. This cycle of consumption and renewal not only sustains the dinosaurs themselves, but also the myriad other creatures that share their habitat. In this same ecosystem, predators like Allosaurus patrol the fringes, their presence keeping herbivore populations in check. This dynamic interplay between predator and prey drives evolution, fostering the development of specialized defenses like the spiked tails of Stegosaurus or the armored plates of Ankylosaurus. These adaptations, in turn, influence the strategies and behaviors of the predators, creating a constantly shifting evolutionary arms race. The forests of the Cretaceous period tell a different story, one of extraordinary biodiversity and intricate ecological relationships. Here, dinosaurs like Iguanodon and Pachycephalosaurus coexist with early flowering plants, whose bright blossoms attract insects and small mammals. These interactions mark the beginning of pollination, a process that would eventually shape the plant life of the modern world. Fossilized pollen grains from this period provide a glimpse into the origins of today's ecosystems, where flowering plants dominate landscapes across the globe. Dinosaurs also contributed to the spread of plant species. Many herbivorous dinosaurs likely acted as seed dispersers, carrying seeds in their digestive systems and depositing them in new locations. This behavior not only supported the growth of diverse plant communities, but also ensured the survival of the dinosaurs themselves by maintaining a steady supply of food. The mutualistic relationship between dinosaurs and plants underscores the interconnectedness of life during the Mesozoic era. The behavior of dinosaurs extended beyond their interactions with plants and predators. Fossilized trackways provide a record of their movements, revealing patterns of migration, foraging, and social interaction. For instance, the parallel tracks of Hadrosaurus suggest group travel, with adults likely guiding and protecting their young. Such evidence points to a level of social organization that parallels that of modern herd animals like elephants and wildebeest. Some dinosaurs exhibited behaviors that hint at complex cognitive abilities. The small theropod Trudon, known for its large brain relative to body size, may have engaged in problem-solving or even rudimentary tool use. While direct evidence of such behaviors is scarce, the anatomical features of Trudon, sharp, grasping claws and forward-facing eyes, suggest a predator capable of intricate hunting strategies and keen observation. The sensory abilities of dinosaurs were as diverse as their forms. Tyrannosaurus rex, for example, possessed an acute sense of smell, enabling it to track prey or scavenge from great distances. Its binocular vision provided excellent depth perception, crucial for judging distances during a chase or ambush. Meanwhile, the hearing of dinosaurs like Parasaurolophus, with its resonating crest, may have been tuned to low-frequency sounds, allowing it to communicate over long distances. Dinosaurs also left their mark on the skies and seas. The pterosaurs, with their lightweight skeletons and vast wingspans, were the first vertebrates to conquer the air. Fossils of pterosaurs reveal a remarkable diversity of forms, from the small, insect-eating Pterodactylus to the massive, soaring Quetzalcoatlus. These creatures exploited niches unavailable to land-dwelling dinosaurs, feeding on fish, scavenging, or even plucking small prey from the ground. In the oceans, marine reptiles like Mosasaurus and Plesiosaurus dominated the food chain. These predators adapted to life in the water with streamlined bodies, powerful tails, and specialized limbs for swimming. Fossil evidence of their stomach contents reveals a diet rich in fish, squid, and even other marine reptiles. The presence of these apex predators ensured the health of marine ecosystems by controlling prey populations and maintaining balance. The fossilization process itself is a testament to the power of Earth's natural forces. When dinosaurs and other organisms died, their remains were often buried in sediment, where they were protected from scavengers and decay. Over millions of years, minerals replaced the organic material, preserving the shape and structure of the bones. This process, while rare, has provided an invaluable window into the past, allowing scientists to reconstruct ancient ecosystems with astonishing detail. Advancements in technology continue to push the boundaries of paleontology. Techniques like synchrotron imaging and isotopic analysis have uncovered details about the diets, growth rates, and even the colors of dinosaurs. For instance, the discovery of melanosomes, pigment-containing structures, has revealed the likely coloration of feathered dinosaurs like Microraptor, whose iridescent feathers may have shimmered in the sunlight. The study of dinosaur eggs and nests has also revolutionized our understanding of their reproductive strategies. Fossilized nests, such as those of Oviraptor, show carefully arranged eggs, suggesting that some dinosaurs exhibited parental care. The discovery of embryos within these eggs provides a glimpse into the earliest stages of dinosaur life, offering clues about their development and hatching behaviors. The end of the Mesozoic era, marked by the Cretaceous-Paleogene extinction event, brought an abrupt halt to the reign of non-avian dinosaurs. Yet, their legacy lives on in the avian dinosaurs that survived and evolved into the birds we see today. From the iridescent plumage of hummingbirds to the predatory instincts of raptors, modern birds carry the genetic and behavioral imprints of their prehistoric ancestors. As you drift further into relaxation, imagine the rhythmic beat of a pteranodon's wings as it glides over an ancient coastline. Picture the gentle rustling of ferns as a stegosaurus moves through the undergrowth, its tail spikes poised to deter any threat. Envision a velociraptor stalking its prey under the cover of twilight, its keen eyes and sharp claws a testament to its predatory prowess. The age of dinosaurs may have ended millions of years ago, but their story continues to unfold with every fossil discovered and every new insight gained. They are a reminder of the resilience and adaptability of life, a testament to the wonders of evolution, and a source of endless fascination for those who seek to understand the past. As the Mesozoic era unfolded, dinosaurs spread across every continent, adapting to climates ranging from lush rainforests to arid deserts. Their global dominance underscores the versatility of these creatures, whose diverse forms allowed them to fill countless ecological niches. From the towering sauropods that grazed on treetops to the swift and cunning raptors that hunted in packs, dinosaurs exemplified evolution's capacity for innovation. Imagine the southern regions of Gondwana, a supercontinent during the early Jurassic. Here, herds of Massospondylus roamed the open plains, their long necks swaying as they fed on ferns and cycads. These early sauropodomorphs were precursors to the giant sauropods of later eras, yet their smaller size allowed them to maneuver through denser vegetation. The fossilized remains of their nests, found in modern-day South Africa, show neatly arranged eggs, suggesting that even at this early stage, dinosaurs exhibited complex reproductive behaviors. In contrast, the northern hemisphere during the late Cretaceous was home to some of the most famous dinosaurs, including Triceratops, Ankylosaurus, and Tyrannosaurus rex. The sprawling plains of what is now North America were dotted with rivers and wetlands, creating a mosaic of habitats that supported an incredible array of life. Herds of Triceratops moved through these landscapes, their horns and frills serving both as defense mechanisms and as tools for social interaction. Fossil evidence of healed injuries on their skulls suggests that these dinosaurs frequently engaged in combat, likely over mates or territory. Nearby, the heavily armored Ankylosaurus lumbered through the undergrowth, its bony plates providing near-impenetrable protection. Its clubbed tail, capable of delivering bone-shattering blows, made it a formidable opponent for any predator daring enough to attack. Fossilized trackways show that these herbivores were solitary, moving slowly but deliberately through their environment in search of low-lying vegetation. Among the predators of this era, Tyrannosaurus rex reigns supreme in popular imagination, but its ecosystem was shared by other fearsome carnivores, such as Dakotaraptor. This large dromaeosaur, with its razor-sharp claws and keen senses, likely hunted in packs, targeting smaller herbivores or the young of larger species. Its agility and speed made it a relentless pursuer, while its intelligence enabled cooperative strategies that increased its hunting success. Dinosaurs' incredible diversity extended beyond their physical forms to their behaviors. Fossilized nesting sites reveal much about how these creatures cared for their young. The discovery of Maiasaura nests, complete with eggshell fragments and juvenile remains, provides evidence of extended parental care. These good mother lizards returned to the same nesting sites year after year, constructing elaborate nests and likely feeding their hatchlings until they were strong enough to fend for themselves. Other dinosaurs exhibited behaviors more akin to modern reptiles. Protoceratops, a small herbivorous ceratopsian, laid eggs in shallow scrapes in the ground, leaving them to incubate in the sun. Fossilized remains of these nests often include adults nearby, suggesting a degree of protective behavior even in these simpler species. The sensory capabilities of dinosaurs were equally varied and impressive. Studies of theropod skulls, such as those of Tyrannosaurus rex and Velociraptor, reveal large olfactory bulbs, indicating an acute sense of smell. This adaptation would have been invaluable for tracking prey or scavenging carcasses. Meanwhile, the discovery of inner ear structures in some dinosaur fossils suggests that their hearing was tuned to specific frequencies, allowing for communication across vast distances. Dinosaurs weren't alone in their prehistoric worlds. They shared their habitats with an array of other life forms, each contributing to the intricate web of Mesozoic ecosystems. Crocodilian ancestors, such as Deinosuchus, lurked in rivers and lakes, their immense size making them formidable predators even to smaller dinosaurs. Insects buzzed through the air, pollinating the early flowering plants that began to diversify during the Cretaceous. Mammals, though small and inconspicuous, scurried through the underbrush, their sharp teeth and agile bodies allowing them to exploit niches untouched by dinosaurs. The skies above were alive with the flapping wings of pterosaurs. While not dinosaurs, these flying reptiles coexisted with them, filling the aerial niche with extraordinary adaptations. Pterodostro, for instance, used its comb-like teeth to filter small organisms from the water, much like modern flamingos. Meanwhile, the massive Quetzalcoatlus soared over the landscapes, its wingspan rivaling that of a small airplane. These creatures remind us that the Mesozoic was a time of innovation not just on land, but also in the skies. Beneath the waves, marine reptiles ruled supreme. Mosasaurus, with its elongated body and powerful tail, was a dominant predator, preying on fish, ammonites, and even other marine reptiles. Its fossilized remains often include bite marks, suggesting that these giants engaged in fierce battles for dominance. Plesiosaurs, with their long necks and paddle-like flippers, hunted smaller prey in the shallow seas. Their graceful movements a stark contrast to the brute force of Mosasaurus. The interplay between these creatures and their environments created dynamic ecosystems that evolved over millions of years. The breakup of Pangaea during the Jurassic and Cretaceous periods introduced new geographical barriers, spurring speciation and regional diversity. Dinosaurs adapted to the unique challenges of their habitats, from the dry deserts of the early Jurassic to the swampy lowlands of the late Cretaceous. The fossil record offers glimpses into the lives of these creatures, from trackways that reveal migration patterns to coprolites that provide clues about their diets. Even the smallest fossils, such as preserved skin impressions or feather imprints, contribute to our understanding of their biology. For example, the discovery of melanosomes in fossilized feathers has allowed scientists to infer the colors and patterns of dinosaurs like Anchiornis and Microraptor. These findings reveal a world as vibrant and colorful as our own, filled with creatures whose appearances would have been as striking as their behaviors. The extinction of non-avian dinosaurs at the end of the Cretaceous marked the end of an era, but their legacy lives on. Birds, the direct descendants of theropod dinosaurs, carry forward many of their ancestors' traits, from their hollow bones to their nesting behaviors. Every songbird, raptor, and hummingbird is a living reminder of the resilience of life, a testament to the unbroken chain of evolution that connects the past to the present. As you sink further into relaxation, let your mind wander through the prehistoric world. Picture a brachiosaurus silhouetted against the rising sun, its neck stretching toward the treetops. Imagine the thunderous roar of a Tyrannosaurus rex echoing through a primeval forest. Visualize the shimmering waters of an ancient sea, where Ichthyosaurus and Plesiosaurus glide through the depths. Their world may be long gone, but its echoes remain, etched into the stones beneath our feet and the skies above our heads. The prehistoric world was not only home to dinosaurs, but also to other remarkable creatures that coexisted and often competed with them for resources. These creatures, from ancient mammals to flying and marine reptiles, filled ecological roles that complemented or rivaled those of dinosaurs. Together, they painted a picture of a planet teeming with life, where every organism played its part in the grand evolutionary symphony. In the skies above, the pterosaurs reigned supreme. These flying reptiles were pioneers of powered flight, their adaptations allowing them to master the air long before birds evolved. Some, like Dimorphodon, had large heads and strong beaks suited for catching fish or small prey. Others, such as Tapejara, featured elaborate head crests, possibly used for display or to help steer during flight. The diversity of pterosaurs was staggering, with species ranging from the tiny, sparrow-sized Nimicolopterus to the gigantic Quetzalcoatlus, whose wingspan stretched up to 40 feet. Imagine the shadow of such a creature gliding over a Mesozoic landscape, a silent testament to the boundless possibilities of evolution. On land, mammals began to carve out niches that would one day lead to their dominance. Though small and often overshadowed by the dinosaurs, these early mammals were remarkably diverse. Species like Morganucodon and Eomea were insectivorous, using their sharp teeth to feed on the abundant arthropods of the time. Others, such as the multituberculates, possessed complex teeth for grinding plant material, showing an early adaptability that would become a hallmark of mammalian evolution. The interaction between mammals and dinosaurs was likely complex. While most mammals were too small to pose a direct threat to dinosaurs, they may have scavenged dinosaur eggs or preyed on hatchlings, adding another layer of challenge to the survival of these ancient reptiles. Conversely, mammals benefited from the ecological opportunities created by dinosaurs, such as access to resources in areas where large herbivores maintained open landscapes. Beneath the surface of the Mesozoic oceans, life thrived in forms both familiar and alien. Marine reptiles, distinct from dinosaurs, dominated the seas. Ichthyosaurs resembled modern dolphins, but were reptiles through and through, their bodies streamlined for swift movement through the water. With large eyes adapted for hunting in dim light and sharp teeth for gripping slippery prey, they were perfectly suited to their environment. Fossils of Ichthyosaurus reveal that these creatures gave live birth, a remarkable adaptation for life at sea. The long-necked plesiosaurs and their shorter-necked relatives, the pliosaurs, also ruled the oceans. Elasmosaurus, a plesiosaur with an astonishingly long neck, likely used its flexibility to dart its head into schools of fish, snapping up prey with quick, precise movements. In contrast, the pliosaur Chronosaurus was built for power, its massive jaws capable of crushing even the toughest shells. These marine reptiles were the apex predators of their domain, their presence shaping the behavior and evolution of countless other marine species. While the oceans and skies were vibrant ecosystems, the terrestrial world of dinosaurs was a dynamic tapestry of interactions and adaptations. The fossilized remains of dinosaurs reveal a staggering array of forms and behaviors, each uniquely suited to its environment. Consider the Camarasaurus, a mid-sized sauropod whose robust teeth allowed it to consume tougher vegetation than its counterparts. This dietary specialization may have reduced competition with other herbivores, ensuring its survival in ecosystems dominated by giants like Brachiosaurus. Predators, too, exhibited extraordinary diversity. Giganotosaurus, one of the largest theropods, prowled the Cretaceous landscapes of South America. With a skull longer than that of Tyrannosaurus rex and teeth designed for slicing flesh, it was a formidable hunter. However, its fossilized bones suggest a lighter build, emphasizing speed and agility over raw power. This contrasts with Tyrannosaurus rex, whose massive jaws and crushing bite force made it a dominant predator in North America. The late Cretaceous also saw the rise of herbivorous dinosaurs with unique defenses. Pachycephalosaurus, for instance, is famous for its domed skull, which could have been used in headbutting contests to establish dominance or attract mates. Similarly, the Stygimoloch, with its spiked skull, represents another example of how herbivores adapted to deter predators or compete within their own species. Among the most enigmatic of dinosaurs are the dromaeosaurs, or raptors. These small to medium-sized predators were agile, intelligent, and often equipped with a deadly sickle-shaped claw on each foot. Velociraptor, though smaller than its Hollywood depiction, was a fierce predator, likely hunting in packs to take down larger prey. Its feathers, revealed through fossil impressions, suggest it may have used them for display or even to assist in maneuverability during a hunt. Feathered dinosaurs like Microraptor blur the line between terrestrial and avian life. This small, four-winged dinosaur likely used its feathered limbs to glide between trees, an early experiment in flight that paved the way for the evolution of birds. Fossil evidence of iridescent plumage suggests that even at this early stage, feathers played a role in communication and mate attraction. The discovery of feathers in non-avian dinosaurs has revolutionized our understanding of their appearance and behavior. These findings challenge the traditional image of dinosaurs as drab, scaly reptiles, revealing a world of vibrant colors and intricate patterns. Feathers provided insulation, aiding thermoregulation, and their evolution into structures capable of flight highlights the adaptability of these ancient creatures. As the Mesozoic era drew to a close, the planet underwent dramatic changes. The asteroid impact at the end of the Cretaceous triggered a cascade of environmental disruptions, from massive wildfires to a nuclear winter caused by airborne debris blocking sunlight. These events led to the extinction of approximately 75% of Earth's species, including all non-avian dinosaurs. However, life persisted in the form of small mammals, birds, and other survivors, setting the stage for a new era of evolution. The legacy of dinosaurs endures not only in their avian descendants, but also in the fossilized remains that continue to fascinate scientists and the public alike. Advances in technology, such as 3D scanning and isotopic analysis, allow researchers to reconstruct their world with unprecedented detail. These discoveries deepen our appreciation for the complexity of their ecosystems and the resilience of life on Earth. As you lie in the quiet of the present, let your mind drift back to the vibrant world of the past. Picture a stegosaurus grazing peacefully beneath towering conifers, its spiked tail swaying rhythmically. Imagine the graceful flight of a pteranodon over a shimmering coastline, its silhouette blending into the horizon. Visualize a Spinosaurus wading through a river, its sail catching the sunlight as it hunts for fish. These scenes, though millions of years removed, remind us of the beauty and interconnectedness of life on our planet. The Mesozoic world was not static. It evolved alongside the creatures that inhabited it. As the Earth shifted and transformed, so too did the ecosystems that supported dinosaur life. Each era brought new challenges and opportunities, shaping the destinies of these remarkable creatures. From lush forests to arid deserts, from the depths of ancient seas to the heights of volcanic peaks, the environments of the Mesozoic era were as diverse as the dinosaurs themselves. In the early Jurassic, vast deserts and arid plains dominated much of the landscape, punctuated by seasonal monsoons that brought life-giving rains. Dinosaurs like Coelophysis thrived in these conditions, their slender bodies and swift movements perfectly adapted to the open terrain. Fossilized trackways of Coelophysis suggest it moved in packs, using its speed and agility to hunt small prey or scavenge on carrion. As the Jurassic period progressed, the environment became increasingly lush, with warm, humid climates supporting dense forests of conifers, cycads, and ginkgos. These forests were home to some of the largest dinosaurs to ever exist, including Brachiosaurus and Diplodocus. These sauropods played a critical role in shaping their ecosystems, their massive appetites driving the evolution of plant defenses like tough leaves and spiny stems. Fossilized stomach contents reveal that sauropods consumed a wide variety of plant material, processing it with the help of gastroliths, stones swallowed to aid in digestion. In the late Jurassic, the landscape continued to diversify. River systems carved through the land, creating fertile floodplains that supported an abundance of life. Along these waterways, dinosaurs like Stegosaurus and Allosaurus flourished. The iconic plates of Stegosaurus, once thought to be purely defensive, may have also helped regulate body temperature or served as a display to intimidate rivals or attract mates. Meanwhile, Allosaurus, with its powerful jaws and sharp claws, was a dominant predator. Its remains often found near the fossilized bones of large herbivores it likely hunted. Moving into the Cretaceous period, the breakup of Pangaea created isolated landmasses, leading to increased regional diversity among dinosaurs. In North America, the rise of hadrosaurs, duck-billed dinosaurs, marked a significant shift in herbivore populations. Species like Edmontosaurus and Parasaurolophus evolved sophisticated dental batteries, enabling them to grind tough vegetation more efficiently than their predecessors. Fossilized nests of hadrosaurs reveal intricate social behaviors, with adults carefully arranging eggs and possibly tending to their young after hatching. In South America, the Cretaceous was dominated by titanosaurs, a group of enormous sauropods that included Argentinosaurus, one of the largest land animals ever discovered. These giants roamed the continent's vast floodplains, their sheer size deterring all but the most determined predators. Fossils of titanosaurs often show signs of healed injuries, suggesting that even these colossal creatures face challenges from predators or rival members of their species. The predators of the Cretaceous were equally diverse and specialized. Tyrannosaurus rex, with its massive skull and bone-crushing bite, was the apex predator of its ecosystem, capable of taking down prey as large as Triceratops. In South America, Giganotosaurus rivaled T-Rex in size, its lighter frame and slicing teeth adapted for hunting sauropods. These predators didn't just rely on brute strength. Their fossils reveal keen sensory adaptations, such as enhanced olfactory bulbs for detecting prey from long distances. In Asia, dinosaurs like Velociraptor and Protoceratops engaged in a predator-prey relationship immortalized in fossilized combat. A famous fossil from Mongolia captures these two species locked in a deadly struggle, with the Velociraptor's sickle claw embedded in the body of its ceratopsian opponent. This snapshot of prehistoric life offers a rare and dramatic glimpse into the interactions between these ancient creatures. The evolution of feathers among theropods added a new dimension to dinosaur behavior and appearance. Fossils of feathered dinosaurs like Sinosauropteryx and Microraptor show that feathers initially evolved for purposes other than flight, such as insulation or display. Over time, these structures became more specialized, leading to the development of flight in avian dinosaurs. The discovery of melanosomes in fossilized feathers has even revealed the likely colors and patterns of some species, such as the iridescent plumage of Microraptor and the reddish-brown stripes of Sinosauropteryx. The role of flight in dinosaur evolution cannot be overstated. The transition from ground-dwelling theropods to the first true birds, such as Archaeopteryx, represents one of the most significant milestones in the history of life on Earth. Fossil evidence shows that Archaeopteryx retained many dinosaurian traits, including teeth and a long bony tail, while also possessing flight feathers and a wishbone. This blend of characteristics highlights the gradual nature of evolutionary change, bridging the gap between non-avian dinosaurs and modern birds. As the Cretaceous period drew to a close, the planet was undergoing significant changes. Volcanic activity in regions like the Deccan Traps released massive amounts of greenhouse gases, altering the climate and stressing ecosystems. Rising sea levels flooded coastal areas, creating new habitats but also displacing established communities. These gradual changes set the stage for the catastrophic asteroid impact that would mark the end of the Mesozoic era. The asteroid, estimated to be about 6 miles wide, struck the Yucatan Peninsula with unimaginable force, releasing energy equivalent to billions of atomic bombs. The impact vaporized rock and created a massive shock wave, followed by fires, tsunamis, and a cloud of debris that blocked sunlight for months. This impact winter caused a dramatic drop in temperatures, leading to the collapse of food chains and the extinction of approximately 75% of all species, including all non-avian dinosaurs. Yet, life persisted. Small mammals, reptiles, and birds found refuge in burrows, caves, and other sheltered environments, where their smaller size and diverse diets helped them survive the harsh conditions. These survivors carried forward the legacy of the Mesozoic, their evolutionary paths paving the way for the rise of mammals and, eventually, humans. Today, the legacy of dinosaurs is evident not only in their avian descendants, but also in the fossilized remains that continue to inspire wonder and curiosity. Advances in paleontology, from CT scanning to molecular analysis, are uncovering new details about their biology, behavior, and environments. Each discovery adds another piece to the puzzle of their story, bringing us closer to understanding these ancient giants. As you relax and let your mind drift, imagine the vibrant world of the Mesozoic era, filled with creatures of every shape and size. Picture a brachiosaurus grazing in a sunlit forest, its massive neck stretching toward the canopy. Visualize a triceratops standing its ground against a stalking Tyrannosaurus rex, its frill and horns a formidable defense. Envision a microraptor gliding between trees, its iridescent feathers catching the light. Their world may be long gone, but its echoes remain, a timeless reminder of life's resilience and creativity. The prehistoric world, spanning millions of years, is a testament to the resilience and adaptability of life. As the ecosystems evolved, so did the creatures that inhabited them, from the towering giants of the Jurassic to the small, nimble predators that hunted in their shadows. The legacy of these ancient organisms persists not only in the fossils they left behind, but in the evolutionary traits passed down through generations, shaping the life forms we see today. In the dense forests of the late Jurassic, sunlight filtered through a thick canopy of towering conifers and cycads. Beneath this cover, the Diplodocus moved in herds, their long tails swaying as they grazed on low-lying plants and occasionally reaching upward to strip foliage from higher branches. Their skeletons, characterized by hollow bones that reduced weight, reveal a creature perfectly adapted for its massive size. These sauropods left behind footprints so large that some fossilized trackways still evoke awe today, marking paths they traveled millions of years ago. In contrast to these herbivorous giants, the Allosaurus prowled the same forests, its powerful legs propelling it through the underbrush in search of prey. With its razor-sharp teeth and robust claws, Allosaurus was a predator built for ambushes. Fossilized bones often show evidence of healed injuries, suggesting these creatures engaged in fierce battles, either with prey or rivals, and lived long enough for their wounds to heal, an indicator of both their resilience and dominance. As the Jurassic gave way to the Cretaceous, the Earth's geography shifted dramatically. The supercontinent Pangaea had long since broken apart, creating isolated landmasses that fostered the evolution of unique dinosaur species. In what is now North America, vast floodplains teemed with life. Herds of Edmontosaurus, a type of hadrosaur, moved in organized groups, their flat, duck-billed mouths adapted for cropping plants from these fertile regions. These dinosaurs were social creatures, as evidenced by fossilized nesting sites and trackways, suggesting they traveled in herds for protection and cooperative feeding. Nearby, Tyrannosaurus rex roamed these same plains. This apex predator, one of the most famous dinosaurs, has long been studied for its immense bite force, capable of crushing bones. However, recent discoveries suggest that T. rex may have also been a social animal, living and hunting in family groups rather than as solitary individuals. Such behavior would have made it even more formidable, allowing it to target large herbivores with a level of coordination previously unimagined. In South America, Argentinosaurus, one of the largest dinosaurs to ever walk the earth, dominated the floodplains and forests. This titanosaur, reaching lengths of up to 100 feet, required enormous amounts of vegetation to sustain its colossal size. Fossilized remains of plant material in nearby sediments provide insights into its diet, revealing that it fed on a variety of ferns, cycads, and conifers. Its size alone made it virtually immune to predation, though younger individuals may have been targeted by predators like Giganotosaurus, a massive theropod that rivaled T-Rex in length. Meanwhile, in the polar regions of the late Cretaceous, dinosaurs adapted to the unique challenges of extended periods of darkness and cold. Fossil evidence from sites in modern-day Antarctica suggests that dinosaurs like Cryolophosaurus thrived in these harsh environments. This theropod, with its distinctive crest, hunted smaller prey and scavenged when necessary, demonstrating the adaptability of dinosaurs to diverse climates. The skies of the Cretaceous were equally dynamic. Pterosaurs, the dominant flying reptiles, had diversified into a wide range of species. Quetzalcoatlus, with its enormous wingspan, soared above the landscapes, likely covering vast distances in search of food. Its lightweight, hollow bones and elongated beak made it a master of the skies. Smaller pterosaurs, such as Pterodostro, filtered small organisms from water using specialized teeth, filling ecological niches similar to modern flamingos. In the oceans, marine reptiles continued to evolve and dominate. Mosasaurus, with its streamlined body and powerful tail, was a top predator in the seas, capable of ambushing prey with incredible speed. Fossils of Mosasaurus have revealed bite marks on other marine reptiles, indicating that these apex predators didn't hesitate to attack rivals. Similarly, plesiosaurs like Elasmosaurus, with their long necks and paddle-like limbs, specialized in hunting fish and squid in shallow waters, their graceful movements contrasting with the raw power of Mosasaurus. As the Cretaceous period neared its end, flowering plants began to flourish, transforming terrestrial ecosystems. These plants, which included early forms of modern trees and shrubs, supported new types of insect pollinators, creating intricate ecological relationships. Dinosaurs like Triceratops and Ankylosaurus adapted to take advantage of this changing vegetation, their diets reflecting the increasing availability of diverse plant species. The asteroid impact that marked the end of the Cretaceous period was a catastrophic event that forever changed the course of life on Earth. The immediate aftermath of the impact, tsunamis, wildfires, and a darkened sky, plunged the planet into chaos. Temperatures dropped sharply, and the lack of sunlight halted photosynthesis, leading to the collapse of ecosystems. The dinosaurs, reliant on stable food sources, were among the many species unable to survive the prolonged environmental upheaval. Yet, even as the age of dinosaurs ended, their legacy endured. Birds, the descendants of theropod dinosaurs, carried forward traits such as feathers, hollow bones, and advanced respiratory systems. Modern paleontology has revealed just how closely linked birds are to their dinosaur ancestors, with some species retaining behaviors and anatomical features that trace directly back to the Mesozoic. The study of dinosaurs continues to evolve, with new discoveries challenging long-held assumptions and providing fresh insights into their lives. Fossilized remains of skin, feathers, and even soft tissues have allowed scientists to reconstruct their appearances with greater accuracy. Advances in technology, such as isotopic analysis and 3D imaging, have deepened our understanding of their diets, growth rates, and behaviors. These techniques have also uncovered surprising details, such as the vibrant colors of some feathered dinosaurs and the social dynamics of species once thought to be solitary. As the Cretaceous period approached its end, the planet was undergoing profound changes. Volcanic eruptions in the Deccan Traps released massive amounts of gases, altering the climate and stressing ecosystems. Rising sea levels created new coastal habitats, while isolating landmasses led to regional diversification. These shifts created a world in flux, setting the stage for the catastrophic asteroid impact that would end the Mesozoic era. The asteroid, striking the Yucatan Peninsula with unimaginable force, unleashed a chain reaction of environmental disasters. Fires, tsunamis, and a nuclear winter caused by debris in the atmosphere devastated ecosystems. The resulting collapse of food chains led to the extinction of approximately 75% of all species, including all non-avian dinosaurs. Yet, even in the face of such devastation, life found a way to persist. Birds, the avian descendants of theropod dinosaurs, adapted to the new conditions, their ability to fly and diverse diets allowing them to survive and thrive. Small mammals, which had lived alongside dinosaurs for millions of years, began to diversify, eventually rising to dominate the post-Mesozoic world. Today, the story of dinosaurs is told through their fossilized remains, which continue to inspire discovery and wonder. Advances in technology, such as CT scanning, isotopic analysis, and molecular studies, have revealed new details about their biology, behavior, and evolution. From their vibrant feathered appearances to their complex social behaviors, dinosaurs were far more dynamic and diverse than previously imagined. As you relax, let your mind wander back to the world they once inhabited. Picture a herd of Apatosaurus moving slowly through a sunlit valley, their massive frames casting long shadows. Envision a Quetzalcoatlus soaring high above a coastal plain, its wings gliding silently through the air. Imagine a Tyrannosaurus rex roaring in a dense forest, its call echoing through the trees. Though their time has passed, the legacy of dinosaurs lives on, a timeless reminder of the resilience and creativity of life on Earth. The Mesozoic era's vast time span provided ample opportunity for life to adapt, diversify, and evolve in ways that remain awe-inspiring even today. Each period of the era, the Triassic, Jurassic, and Cretaceous, offered unique environments and challenges that shaped the creatures living within them. From the sprawling plains of North America to the dense forests of South America, from the windswept deserts of Asia to the submerged coastal regions of Europe, life thrived in forms both grand and subtle, contributing to ecosystems that were as complex as they were interconnected. In the early Jurassic, life rebounded from the Permian-Triassic extinction, the most severe mass extinction event in Earth's history. During this time, the first dinosaurs began to rise in prominence. Small theropods like Coelophysis and Eoraptor roamed the arid landscapes, their agility and sharp senses allowing them to hunt small prey and evade larger predators. These early dinosaurs were opportunists, their ability to adapt to shifting climates and ecosystems paving the way for their eventual dominance. As the Jurassic period progressed, lush forests and expansive wetlands became the backdrop for the rise of sauropods, the largest animals to ever walk the Earth. Dinosaurs like Brachiosaurus and Apatosaurus towered over their environments, their long necks enabling them to reach the highest branches of conifers and cycads. The immense size of these creatures not only deterred predators, but also created microhabitats within their shadows. Birds, insects, and small mammals likely thrived in these safe havens, feeding on the insects and plants stirred up by the sauropods' movements. In the shadow of these giants, smaller dinosaurs like Stegosaurus and Dryosaurus thrived. Stegosaurus, with its distinctive plates and spiked tail, was a walking fortress, its anatomy uniquely adapted for defense and display. Studies of its fossils suggest that blood vessels running through its plates may have helped regulate its body temperature or allowed it to flush its plates with blood for mating displays or intimidation. Predators of the Jurassic, like Allosaurus and Ceratosaurus, were masters of their domain. Allosaurus, with its massive skull and serrated teeth, relied on ambush tactics to take down prey. Fossil evidence of healed wounds on prey species like Apatosaurus suggests that these interactions were fierce, with both predator and prey suffering injuries in the struggle for survival. The Cretaceous period brought with it even greater diversity as the continents continued to drift apart. The breakup of Pangaea created isolated ecosystems, driving the evolution of unique species. In North America, the western interior seaway bisected the continent, creating coastal plains and inland seas teeming with life. Here, Tyrannosaurus rex emerged as the apex predator. Fossilized remains of T. rex reveal not only its immense size and bone-crushing bite, but also evidence of sensory adaptations that made it an efficient hunter and scavenger. Herbivorous dinosaurs like Triceratops and Edmontosaurus thrived in these ecosystems. Triceratops, with its 3 horns and large frill, likely used these features for both defense and social interaction. Fossilized trackways suggest that these dinosaurs moved in herds, their numbers providing protection against predators. Meanwhile, the duck-billed Edmontosaurus roamed in large groups, its grinding teeth perfectly suited for processing the tough vegetation of the coastal plains. In Asia, The deserts of the Gobi region were home to dinosaurs like Velociraptor and Protoceratops. Fossils from this region often reveal dramatic stories, such as the famous fighting dinosaurs fossil that captures a Velociraptor and Protoceratops locked in combat. This fossil offers a rare glimpse into the interactions between predator and prey, preserved in stunning detail for millions of years. South America, with its vast floodplains and forests, was the domain of titanic dinosaurs like Argentinosaurus. These massive sauropods, reaching lengths of over 100 feet, were the ultimate herbivores, consuming vast quantities of vegetation to sustain their size. Their predators, such as Giganotosaurus and Mapusaurus, evolved to meet the challenge of hunting such giants. Fossil evidence suggests that these predators may have hunted in packs, working together to isolate and take down their enormous prey. The skies of the Cretaceous were alive with pterosaurs, whose mastery of flight allowed them to dominate the aerial realm. Quetzalcoatlus, with its wingspan rivaling that of a small airplane, soared over the landscapes, scavenging and hunting small prey. Smaller pterosaurs, like Nyctosaurus, used their long, pointed crests for display or steering during flight, showcasing the incredible diversity of these flying reptiles. In the oceans, marine reptiles like Mosasaurus and Plesiosaurus ruled the waves. Mosasaurus, with its streamlined body and powerful tail, was a top predator, capable of ambushing prey with lightning speed. Fossilized remains of Mosasaurus often include bite marks and injuries, evidence of fierce competition among these apex predators. In contrast, Plesiosaurus, with its long neck and paddle-like flippers, specialized in hunting smaller prey in shallow waters, using its flexibility to dart its head into schools of fish. The evolution of feathers among theropods added a new dimension to dinosaur diversity. Microraptor, with feathers on all four limbs, was an early experiment in flight, using its adaptations to glide between trees. The discovery of melanosomes in its fossilized feathers has even allowed scientists to reconstruct its coloration, revealing iridescent plumage that would have dazzled in the sunlight. Similarly, Archaeopteryx, often considered the first true bird, bridged the gap between its dinosaur ancestors and modern avians, its feathered wings enabling it to achieve powered flight. As the Cretaceous period drew to a close, the Earth was on the brink of dramatic change. The asteroid impact that created the Chicxulub crater unleashed destruction on an unprecedented scale. Fires, tsunamis, and a nuclear winter caused by debris in the atmosphere devastated ecosystems. Photosynthesis halted, leading to the collapse of food chains and the extinction of approximately 75% of all species, including all non-avian dinosaurs. Despite this devastation, life persisted. Birds, the direct descendants of theropod dinosaurs, adapted to the New World, their small size and diverse diets giving them an advantage in the harsh post-impact environment. Mammals, which had lived alongside dinosaurs for millions of years, began to diversify, eventually rising to dominate the Cenozoic era. Today, the legacy of dinosaurs is all around us. Advances in paleontology, from 3D imaging to molecular analysis, continue to reveal new insights into their lives, behaviors, and appearances. From their vibrant feathered colors to their complex social structures, dinosaurs were far more dynamic and diverse than previously imagined. As you relax and let your imagination wander, picture the vibrant world of the Mesozoic. See the sprawling plains where herds of Triceratops graze, their horns glinting in the sunlight. Envision a Quetzalcoatlus soaring over a prehistoric coastline, its shadow stretching across the waves. Feel the rumble of a Tyrannosaurus rex stalking through a dense forest, its gaze fixed on its next meal. Though their time has passed, their legacy lives on, a reminder of the resilience and wonder of life on Earth. The intricate web of life during the Mesozoic era reveals a world where dinosaurs and their contemporaries adapted to an array of environments, forging intricate relationships with the land, water, and sky. This age was not merely about survival but innovation, as species developed remarkable traits and behaviors to thrive in a constantly shifting world. In the forests of the late Jurassic, towering conifers and cycads provided cover and sustenance for a variety of dinosaurs. The massive Diplodocus moved gracefully among the trees, its whip-like tail occasionally swishing to ward off predators. Fossil evidence of this sauropod reveals a skeleton designed for efficient movement, with hollow bones reducing weight and enabling its immense frame to navigate the dense undergrowth. On the open plains, herds of Stegosaurus grazed in relative safety. Their distinctive plates, arranged in alternating rows, likely served multiple purposes: thermoregulation, species recognition, and intimidation. These herbivores, while formidable with their spiked tails, faced constant threats from predators like Allosaurus. Paleontologists have discovered fossilized remains bearing marks of attacks, evidence of the brutal interactions that defined their existence. The late Cretaceous saw a proliferation of ceratopsians like Triceratops and Styracosaurus. These horned dinosaurs roamed in large herds, their social behaviors reflected in fossilized trackways and nesting sites. Their frills and horns were not merely for defense. They also played a role in mating rituals and displays of dominance within the herd. Fossils of Triceratops show healed wounds on their frills, suggesting these features were often used in combat, possibly during territorial disputes or mating competitions. Among the most iconic predators of the Mesozoic was Tyrannosaurus rex. With its massive jaws, robust teeth, and bone-crushing bite force, T. rex was built for efficiency. Yet, recent studies suggest it may not have relied solely on active hunting. Fossilized bones of prey animals often show signs of scavenging, indicating that T. rex was an opportunist, capable of making the most of any available resource. This adaptability contributed to its dominance as an apex predator. In South America, the enormous Giganotosaurus and Mapusaurus hunted the colossal sauropods that roamed the floodplains. These predators were well adapted for their role, with long, slicing teeth and powerful hind limbs. Fossil evidence suggests they may have hunted cooperatively, targeting juvenile or weakened members of sauropod herds. Such behaviors reflect a level of strategy that hints at complex social structures within these predator species. Smaller predators like Velociraptor and Deinonychus relied on agility and intelligence. Fossilized remains of Velociraptor show sharp, curved claws on their hind limbs, which were used to grip and disembowel prey. Evidence from fossilized trackways and bone beds suggests that some dromaeosaurs may have hunted in packs, increasing their effectiveness against larger prey. These behaviors highlight the diversity of predatory strategies among theropods. Above the forests and plains, pterosaurs ruled the skies. The late Cretaceous saw the emergence of some of the largest flying animals in history, including Quetzalcoatlus. With its 40-foot wingspan, this pterosaur was capable of long-distance flight, likely scavenging along coastlines or hunting small prey in open areas. Its lightweight skeleton and powerful wing muscles made it a master of the air. Smaller pterosaurs, like Pterodostro, adapted to specific niches. This filter-feeding pterosaur used its fine, bristle-like teeth to sift plankton and small invertebrates from shallow waters, much like modern flamingos. The diversity of pterosaur forms underscores their ability to exploit a wide range of habitats and food sources. While dinosaurs ruled the land, marine reptiles dominated the seas. Mosasaurus, a top predator of the late Cretaceous, was built for speed and power. Fossilized remains of Mosasaurus reveal a streamlined body, powerful tail, and conical teeth designed for gripping slippery prey. Its diet included fish, ammonites, and even other marine reptiles, making it the apex predator of its domain. In contrast, Plesiosaurus specialized in shallow waters. With its long neck and paddle-like flippers, this marine reptile was an agile hunter, darting its head into schools of fish. Fossilized stomach contents have confirmed its preference for small, fast-moving prey, reflecting its adaptation to a specific ecological niche. Feathers, one of the most transformative adaptations in vertebrate history, began as simple structures for insulation. Over millions of years, feathers evolved into tools for display, camouflage, and eventually flight. The discovery of feathered dinosaurs like Sinosauropteryx and Microraptor has reshaped our understanding of dinosaur biology, revealing a world far more colorful and dynamic than once imagined. Microraptor, a small, four-winged dinosaur, represents a critical stage in the evolution of flight. Its feathers allowed it to glide between trees, evading predators and hunting small prey. The discovery of melanosomes in its feathers has revealed iridescent coloration, adding a new layer of complexity to our perception of these ancient creatures. Similarly, Archaeopteryx, often regarded as the first bird, retained many dinosaurian traits, including teeth, clawed wings, and a bony tail. Fossilized impressions of its feathers show a level of sophistication that enabled powered flight, marking a significant evolutionary leap. The end of the Cretaceous was marked by one of the most dramatic extinction events in Earth's history. The asteroid impact that created the Chicxulub crater unleashed catastrophic environmental changes. Fires, tsunamis, and a nuclear winter, caused by atmospheric debris, plunged the planet into darkness, halting photosynthesis and collapsing food chains. Despite the devastation, life found ways to persist. Birds, the only surviving dinosaurs, adapted to the new conditions, their small size and diverse diets giving them an advantage. Mammals, which had coexisted with dinosaurs for millions of years, began to diversify, filling niches left vacant by the extinction. Today, the legacy of dinosaurs is evident in every bird that takes flight. Their fossilized remains continue to inspire wonder and curiosity, offering a window into a world of incredible diversity and resilience. Advances in paleontology, from CT scanning to molecular analysis, have deepened our understanding of their biology, behavior, and evolution. As you let your imagination wander, picture the vibrant world they inhabited. See a flock of microraptors darting between trees, their iridescent feathers shimmering in the sunlight. Envision a herd of triceratops grazing on a sunlit plain, their horns glinting as they move in unison. Feel the thunderous rumble of a Tyrannosaurus rex as it roars through a dense forest, asserting its dominance. Though their reign has ended, the story of dinosaurs continues to inspire, reminding us of the incredible resilience and creativity of life on Earth. The Mesozoic era was a time of perpetual evolution, where every creature contributed to the shaping of ecosystems that would echo through history. As the Jurassic period transitioned into the Cretaceous, the landscapes themselves were undergoing dramatic transformations. Plate tectonics continued to split the supercontinent Pangaea, creating isolated landmasses that fostered the rise of new species. Vast inland seas appeared, separating regions and creating unique ecological pockets. These isolated environments pushed evolutionary boundaries, allowing species to adapt in ways that made them uniquely suited to their surroundings. One of the most striking examples of these adaptations was the evolution of the hadrosaurs, or duck-billed dinosaurs. These herbivorous giants flourished during the late Cretaceous, their complex dental structures setting them apart from their predecessors. Each tooth in a hadrosaur's mouth was part of a tightly packed battery, designed to grind tough vegetation with incredible efficiency. This dental innovation allowed hadrosaurs like Edmontosaurus and Lambeosaurus to exploit the wide range of plant materials, ensuring their survival in environments where resources could be scarce or seasonal. The social behaviors of hadrosaurs were equally fascinating. Fossilized trackways and nesting sites reveal that these dinosaurs lived in large herds, a strategy that provided protection against predators. Nesting sites, such as those attributed to Maiasaura, show evidence of repeated use, with adults carefully arranging eggs and possibly tending to their young. This parental care, a trait shared with modern birds, underscores the complex social structures that hadrosaurs likely maintained. Predators during the late Cretaceous were no less innovative. The infamous Tyrannosaurus rex dominated the ecosystems of North America, its massive size and bone-crushing bite force making it one of the most formidable carnivores of its time. However, recent studies suggest that T. rex was not merely a brute. Its keen senses, including an acute sense of smell and forward-facing eyes for depth perception, made it a highly effective hunter. Fossilized remains of prey animals often show healed injuries, indicating that some managed to escape its attacks, testament to the ferocity of these encounters. In the southern continents, predators like Giganotosaurus and Carcharodontosaurus took on a similar role. These theropods, slightly larger than T. rex, were built for speed and agility. Their slicing teeth and powerful hind limbs allowed them to target the massive sauropods that roamed the region. Fossil evidence suggests that these predators may have hunted in packs, a behavior that would have increased their chances of bringing down such colossal prey. Today, the legacy of dinosaurs is evident in the fossils they left behind and the birds that continue to soar across our skies. Advances in technology have transformed paleontology, uncovering new insights into their biology, behavior, and environments. Each discovery adds to our understanding of the incredible diversity and adaptability of these ancient creatures. As you rest, imagine the vibrant world of the Mesozoic. Picture a herd of Diplodocus moving slowly through a sunlit valley, their long necks swaying as they graze. Envision a flock of microraptors gliding between the trees, their iridescent feathers shimmering in the light. Feel the rumble of a Tyrannosaurus rex as it prowls through the underbrush, its powerful form a testament to nature's creativity. Though their time has passed, the story of dinosaurs continues to inspire, reminding us of the resilience and wonder of life on Earth. The birth of lineages that persist today. As we delve deeper into the rich tapestry of Mesozoic life, the intricate connections between species, their environments, and the planet itself come to light. During the early Cretaceous, flowering plants, or angiosperms, began to emerge and spread across the landscape. This evolutionary milestone transformed terrestrial ecosystems, introducing a new food source that influenced the diets and behaviors of herbivorous dinosaurs. Fossilized pollen grains and coprolites containing traces of flowering plants provide direct evidence of this interaction. Dinosaurs like Iguanodon, with its beak-like structure and robust teeth, adapted to process tougher vegetation, showcasing the symbiotic relationship between flora and fauna. As flowering plants diversified, so too did the insects that pollinated them. These early pollinators, including beetles, flies, and primitive bees, played a crucial role in the success of angiosperms. This mutualistic relationship further shaped the diets of dinosaurs, as herbivores increasingly relied on the fruits and seeds produced by flowering plants. Fossilized remains of stomach contents and coprolites reveal the dietary flexibility of herbivorous dinosaurs, highlighting their ability to exploit these new resources. The mid-Cretaceous also witnessed the rise of ankylosaurs, the heavily armored herbivores that roamed the ancient landscapes. Ankylosaurus, with its bony plates and clubbed tail, was a walking fortress, its defenses capable of deterring even the largest predators. Fossilized remains of ankylosaurs often show signs of healed injuries, suggesting that these dinosaurs frequently used their tail clubs in combat, either against predators or rivals. Their low-slung bodies and specialized teeth allowed them to graze on low-lying vegetation, carving out a niche distinct from other herbivores of the time. In the same period, ceratopsians like Triceratops and Styracosaurus continued to thrive. These horned dinosaurs evolved elaborate frills and horns, which served a variety of purposes, from defense to display. Fossilized remains of ceratopsians reveal intricate vascular networks within their frills, indicating that they may have been flushed with blood to display vibrant colors during courtship or social interactions. The discovery of trackways and nesting sites suggests that ceratopsians lived in herds, their social structures providing protection and facilitating the care of their young. Predators evolved in tandem with their herbivorous prey, adapting to the challenges posed by these heavily armored and socially coordinated dinosaurs. In North America, Tyrannosaurus rex represented the pinnacle of theropod evolution. Its massive skull, filled with bone-crushing teeth, and its keen senses made it a formidable hunter and scavenger. Fossilized bite marks on the bones of herbivores like Triceratops and Edmontosaurus offer direct evidence of the predatory habits of T. rex. Studies of its leg bones and musculature suggest that it was capable of surprising bursts of speed, enabling it to ambush prey in open environments. In South America, the giant theropod Giganotosaurus hunted alongside Mapusaurus, both predators targeting the enormous sauropods like Argentinosaurus. These predators likely employed pack hunting strategies, a hypothesis supported by the discovery of bone beds containing multiple individuals of the same species. Their sharp, slicing teeth and robust builds allowed them to tackle prey much larger than themselves, underscoring the evolutionary arms race between predator and prey. The skies of the Cretaceous were dominated by pterosaurs, whose diversity rivaled that of the dinosaurs below. Quetzalcoatlus, the largest flying animal known, soared over vast distances, its wingspan enabling it to glide effortlessly for hours. This pterosaur likely scavenged along coastlines or hunted small prey, its sharp beak perfectly adapted for its varied diet. Smaller pterosaurs, like Rhamphorhynchus, specialized in catching fish, their sharp teeth and aerodynamic bodies enabling them to snatch prey directly from the water's surface. Marine ecosystems were equally dynamic, with a variety of reptiles occupying the oceans. Mosasaurus, a dominant predator of the seas, was built for speed and power, its streamlined body and powerful tail enabling it to pursue prey with precision. Fossil evidence of bite marks and healed injuries suggests that these apex predators frequently engaged in territorial disputes or mating battles. In contrast, Plesiosaurus, with its long neck and paddle-like limbs, specialized in hunting smaller prey in coastal waters. Its fossils, often found with stomach contents intact, provide valuable insights into its diet and ecological role. The evolution of feathers among theropod dinosaurs added a new dimension to the Mesozoic world. Fossils of species like Microraptor and Anchiornis reveal feathered bodies that served multiple purposes, from insulation to display and even flight. Microraptor, with feathers on all four limbs, likely used its adaptations to glide between trees, evading predators and catching prey. The discovery of melanosomes in its feathers has revealed iridescent coloration, showcasing the vibrant diversity of these ancient creatures. Archaeopteryx, often considered the first true bird, marked a significant milestone in the transition from dinosaurs to avians. Retaining many dinosaurian traits, such as teeth and clawed wings, Archaeopteryx also possessed feathers capable of powered flight. Fossilized impressions of its plumage reveal intricate details, providing a glimpse into the early stages of avian evolution. The end of the Cretaceous was marked by the catastrophic asteroid impact that created the Chicxulub crater. This event triggered massive wildfires, tsunamis, and a prolonged nuclear winter, plunging the Earth into darkness and halting photosynthesis. The resulting collapse of food chains led to the extinction of approximately 75% of all species, including all non-avian dinosaurs. Yet, amidst this devastation, life persisted. Birds, the only surviving lineage of dinosaurs, adapted to the new environment, their small size and diverse diets giving them an advantage. Mammals, which had lived alongside dinosaurs for millions of years, began to diversify, eventually rising to dominate the post-Mesozoic world. The extinction of the dinosaurs marked the end of one chapter in Earth's history, but also set the stage for the emergence of new forms of life. Today, the story of the Mesozoic continues to unfold through the study of fossils and the birds that carry on the legacy of their dinosaurian ancestors. Advances in technology, from 3D imaging to molecular analysis, have deepened our understanding of these ancient creatures, revealing the complexity and adaptability of life during this extraordinary era. As you reflect on the vibrant world of the Mesozoic, imagine a herd of Argentinosaurus moving slowly across a prehistoric floodplain, their immense frames casting long shadows in the golden light. Picture a flock of Microraptors darting between trees, their iridescent feathers catching the sunlight. Hear the distant call of a Quetzalcoatlus as it glides effortlessly over an ancient coastline. Though their time has passed, the story of the dinosaurs remains a testament to the resilience and wonder of life on Earth, a source of inspiration that continues to captivate and enlighten. As the Mesozoic era unfolded, the Earth itself was in constant flux. Shifting continents, changing climates, and evolving ecosystems shaped the lives of its inhabitants. Dinosaurs, pterosaurs, marine reptiles, and early mammals each played a part in this vibrant tapestry, adapting to their environments with remarkable ingenuity. Every fossil on Earth from this period adds a new layer to our understanding of the complexities of life on ancient Earth. By the mid-Cretaceous, the world was a patchwork of distinct ecosystems. The breakup of Pangaea had created isolated landmasses, driving evolutionary divergence among species. This geographical separation gave rise to a wide variety of dinosaurs, each adapted to the unique challenges and opportunities of their environments. In North America, the western interior seaway divided the continent, creating vast coastal plains and inland waterways. Along these shores, dinosaurs like Triceratops and Edmontosaurus thrived. Triceratops, with its iconic horns and frill, likely used these features for both defense and display. Fossilized remains of their frills reveal signs of vascularization, suggesting that they could flush blood into these structures to display vibrant colors, possibly for mating or social dominance. Trackways indicate that Triceratops may have traveled in herds, their numbers offering protection against predators like Tyrannosaurus rex. The apex predator of this region, Tyrannosaurus rex, was a marvel of evolutionary engineering. Its massive skull housed bone-crushing teeth, while its robust hind limbs allowed it to cover short distances with surprising speed. Studies of its olfactory bulbs suggest an acute sense of smell, enabling it to track prey or detect carcasses from miles away. Fossil evidence of bite marks on the bones of prey species reveals the devastating power of its jaws, capable of puncturing even the thickest armor. In the southern hemisphere, the floodplains of South America were dominated by sauropods like Argentinosaurus and Dreadnoughtus. These giants, some of the largest animals to ever walk the earth, required immense amounts of vegetation to sustain their massive frames. Fossilized trackways suggest that sauropods moved in herds, their social structures providing protection for the young and ensuring access to food. Predators like Giganotosaurus and Mapusaurus evolved to hunt these giants, using their slicing teeth and cooperative hunting strategies to target weaker members of the herd. Asia's Cretaceous landscapes were home to a diverse array of species, from feathered theropods to herbivorous ceratopsians. The deserts of what is now Mongolia provided a unique setting for predator-prey dynamics, with Velociraptor and Protoceratops often found in close association. The fighting dinosaurs fossil, which captures these two species locked in combat, offers a rare and dramatic glimpse into their interactions. This snapshot of ancient life preserves the fierce struggle that defined their existence. Feathered dinosaurs like Microraptor and Anchiornis added a new dimension to these ecosystems. Microraptor, with its 4 feathered limbs, was an early experiment in flight, using its adaptations to glide between trees. Fossilized remains of Microraptor show evidence of iridescent plumage, suggesting that its feathers may have been used for display as well as flight. These discoveries underscore the evolutionary link between dinosaurs and modern birds, highlighting the gradual transition from terrestrial predators to avian ancestors. In the skies, pterosaurs continued to dominate. Quetzalcoatlus, one of the largest flying animals ever discovered, soared over vast distances, likely scavenging along coastlines or hunting small prey. Its lightweight skeleton and massive wings enabled it to conserve energy while gliding for hours. Smaller pterosaurs, like Pterodostro, adapted to specific niches, using their fine, comb-like teeth to filter plankton from shallow waters. The oceans of the Cretaceous were no less dynamic. Marine reptiles like Mosasaurus and Plesiosaurus ruled the seas, their adaptations reflecting the challenges of aquatic life. Mosasaurus, with its streamlined body and powerful tail, was built for speed and power, preying on fish, ammonites, and even other marine reptiles. Fossilized remains of Mosasaurus often show evidence of territorial disputes, with bite marks and injuries indicating fierce competition among these apex predators. Plesiosaurus, in contrast, was adapted for hunting in shallow coastal waters. Its long neck and paddle-like limbs allowed it to dart its head into schools of fish, while its robust body provided stability in turbulent waters. Fossilized stomach contents reveal a diet of small fish and squid, highlighting its role as a specialized predator in its ecosystem. As the Cretaceous period progressed, flowering plants became increasingly dominant, transforming terrestrial ecosystems. These angiosperms introduced new food sources that influenced the diets of herbivorous dinosaurs. Fossilized coprolites containing traces of flowering plants reveal that dinosaurs like Iguanodon adapted to exploit these resources, their teeth and beaks allowing them to process tough vegetation efficiently. The spread of flowering plants also supported the diversification of pollinators, including early bees and butterflies, further shaping the evolution of Mesozoic ecosystems. The end of the Cretaceous brought one of the most significant extinction events in Earth's history. The asteroid impact that created the Chicxulub crater unleashed a chain of catastrophic events, including wildfires, tsunamis, and a prolonged nuclear winter. The resulting collapse of food chains led to the extinction of approximately 75% of all species, including all non-avian dinosaurs. However, life persisted. Birds, the avian descendants of theropod dinosaurs, adapted to the New World, their small size and diverse diets allowing them to thrive. Mammals, which had coexisted with dinosaurs for millions of years, began to diversify, filling the ecological niches left vacant by the extinction. Today, the legacy of the Mesozoic lives on in the fossils that continue to reveal the secrets of this ancient world. Advances in paleontology, from isotopic analysis to 3D modeling, have transformed our understanding of these creatures, uncovering details about their biology, behavior, and environments. Each discovery adds to the story, painting a vivid picture of life on a planet that was both familiar and alien. As you reflect on the wonders of the Mesozoic, imagine a herd of Apatosaurus moving slowly across a sunlit plain, their long necks swaying as they graze on the treetops. Picture a flock of microraptors darting between the trees, their iridescent feathers shimmering in the dappled light. Feel the rumble of a Tyrannosaurus rex as it prowls through the underbrush, its gaze fixed on its next meal. Though their time has passed, their story remains a testament to the resilience and creativity of life on Earth, an enduring source of wonder and inspiration. Feathered dinosaurs bridged the gap between terrestrial life and the avian world. Fossils of Microraptor and Anchiornis reveal their ability to glide between trees, their feathers providing both lift and insulation. The discovery of melanosomes in these fossils has even allowed scientists to reconstruct their colors, revealing a world filled with iridescent plumage and intricate patterns. These findings challenge traditional notions of dinosaurs as dull, scaly creatures, replacing them with a vibrant, dynamic picture of prehistoric life. The discovery of nesting sites and fossilized eggs has provided remarkable insights into the reproductive strategies of dinosaurs. The nests of Maiasaura, carefully constructed and arranged, suggest a level of parental care that parallels that of modern birds. Fossilized embryos within these nests reveal the early development of dinosaurs, shedding light on their growth rates and life stages. Some species, like Protoceratops, laid their eggs in simple scrapes, relying on the environment to provide the warmth needed for incubation. These diverse strategies reflect the adaptability and ingenuity of dinosaurs in ensuring the survival of their offspring. As the Cretaceous period drew to a close, the Earth was a planet in flux. Rising sea levels, volcanic activity, and climatic shifts created new challenges for life. The asteroid impact that ended the Mesozoic era was the final blow, triggering a mass extinction that wiped out approximately 75% of Earth's species. Yet, even in the face of such devastation, life found a way. Birds, the descendants of theropod dinosaurs, survived and thrived, their small size and diverse diets giving them an edge in the harsh post-impact world. Today, the study of dinosaurs continues to advance, driven by new technologies and discoveries. Fossils once thought to be static relics are now analyzed with techniques like CT scanning and isotopic analysis, revealing details about their diets, growth rates, and even their appearances. The discovery of soft tissues in some fossils has opened new avenues of research, allowing scientists to study the molecular composition of dinosaurs and gain insights into their physiology. As you sink further into relaxation, imagine the vibrant world of the Mesozoic era. Picture a herd of Apatosaurus moving slowly through a fern-covered valley, their long necks swaying as they graze. Envision a Quetzalcoatlus soaring high above, its wings casting a shadow over the landscape below. Feel the ground tremble as a Tyrannosaurus rex roars, its call echoing through a dense forest. The world of dinosaurs may be millions of years removed from our own, but its echoes remain, a timeless reminder of the resilience and creativity of life on Earth. As the story of the dinosaurs continues to captivate imaginations, scientists are unraveling even more intricate details about their lives, environments, and interactions. Each fossil discovery brings a new layer of understanding, allowing us to piece together a vivid mosaic of the Mesozoic era. These ancient worlds were dynamic, filled with challenges and opportunities that shaped the creatures we now study with awe. The ecosystems of the Mesozoic were teeming with life, each species playing a role in maintaining the balance of its environment. Herbivorous dinosaurs, such as the duck-billed hadrosaurs, were critical to these systems. Their grazing not only shaped the plant life around them, but also influenced the evolution of predator species. The discovery of Edmontosaurus fossils in herds indicates that these dinosaurs likely traveled in groups, offering mutual protection against predators while efficiently exploiting food sources. Hadrosaurs like Lambeosaurus and Parasaurolophus were particularly fascinating due to their cranial crests. These structures, connected to their nasal passages, likely allowed them to produce resonant calls that could carry over long distances. Fossilized remains suggest that these calls were used for communication within herds, such as signaling danger, attracting mates, or maintaining group cohesion. Imagine the haunting sound of a Parasaurolophus call echoing through the misty forests of the late Cretaceous. The defensive adaptations of herbivorous dinosaurs were as varied as their forms. The armored Ankylosaurus, with its bony plates and clubbed tail, was a near-impenetrable fortress. Fossilized tail clubs show signs of wear, indicating that these dinosaurs used them actively, perhaps to fend off predators like Tyrannosaurus rex. Similarly, the frilled and horned ceratopsians, such as Triceratops and Styracosaurus, used their elaborate headgear both as a defense mechanism and for social or mating displays. Predators, in turn, evolved strategies to overcome these defenses. Tyrannosaurus rex, with its bone-crushing bite, could penetrate the armor of even the most well-protected herbivores. Its strong legs and keen senses made it a highly effective hunter, but fossil evidence also suggests that it scavenged when necessary, taking advantage of carcasses left behind by other predators or environmental events. The versatility of T. rex is a testament to its adaptability, which contributed to its status as one of the apex predators of its time. In South America, the enormous Giganotosaurus hunted in environments dominated by massive sauropods like Argentinosaurus. With slicing teeth and a lighter build compared to T. rex, Giganotosaurus likely relied on speed and precision to take down its prey. Fossilized remains of sauropods with bite marks matching Giganotosaurus teeth suggest that these predators targeted the more vulnerable juveniles or sick individuals in herds. Feathered dinosaurs added another layer of complexity to these ancient ecosystems. Microraptor, a small theropod with feathered limbs, was among the first creatures to experiment with gliding. Its ability to move between trees likely gave it an advantage in avoiding ground-based predators and accessing food sources. Fossil evidence of Microraptor stomach contents reveals a diverse diet that included fish, small mammals, and even other dinosaurs, highlighting its versatility as a predator. Larger feathered theropods, such as Deinonychus, were pack hunters, coordinating their efforts to take down prey much larger than themselves. Their intelligence and agility, combined with their sharp claws and teeth, made them formidable predators. The discovery of fossilized trackways showing multiple individuals moving in unison supports the idea of cooperative hunting behaviors, offering a glimpse into the social structures of these ancient carnivores. While the land was dominated by dinosaurs, the skies and seas were no less spectacular. Pterosaurs, the first vertebrates to achieve powered flight, continued to diversify throughout the Mesozoic. The massive Quetzalcoatlus, with a wingspan rivaling that of a small airplane, was likely a scavenger, using its long beak to feed on carrion. Smaller pterosaurs, like Rhamphorhynchus, were adept fish hunters, their sharp teeth and strong jaws adapted for gripping slippery prey. The marine ecosystems of the Mesozoic were equally dynamic. Mosasaurus, with its sleek body and powerful tail, was a top predator in the oceans, preying on fish, ammonites, and even other marine reptiles. Fossilized remains of Mosasaurus reveal puncture wounds and bite marks, evidence of fierce competition among these apex predators. In contrast, plesiosaurs like Elasmosaurus, with their long necks and paddle-like flippers, were specialized hunters, using their flexibility to catch smaller, faster prey in shallow waters. The role of plants in these ecosystems cannot be overlooked. The emergence of flowering plants during the Cretaceous introduced new ecological dynamics, supporting a variety of pollinators, including early insects. Dinosaurs like iguanodon adapted to take advantage of these changes, their beaks and teeth allowing them to process tougher vegetation. Fossilized pollen grains and plant material in coprolites provide a direct link between these dinosaurs and the changing flora of their time. As the Mesozoic era approached its end, the Earth underwent significant geological and climatic changes. Volcanic activity in regions like the Deccan Traps released massive amounts of greenhouse gases, altering global temperatures and stressing ecosystems. Rising sea levels flooded coastal areas, creating new habitats but also displacing established species. These gradual changes set the stage for the catastrophic asteroid impact that would bring the Mesozoic to a close. The asteroid, striking the Yucatan Peninsula with the force of billions of atomic bombs, unleashed a cascade of destruction. Fires, tsunamis, and a nuclear winter, caused by debris blocking sunlight, devastated ecosystems. The resulting mass extinction wiped out approximately 75% of all species, including all non-avian dinosaurs. Yet, amidst the devastation, life persisted. Small mammals, reptiles, and birds adapted to the new conditions, their size and diverse diets giving them a survival advantage. These survivors would go on to shape the evolutionary path of the planet, paving the way for the rise of mammals and, eventually, humans. Today, the legacy of dinosaurs lives on, not only in their avian descendants but also in the fossils that continue to fascinate scientists and enthusiasts alike. Advances in technology, such as CT scanning and molecular analysis, have transformed paleontology, allowing researchers to uncover details about dinosaur biology, behavior, and evolution that were once unimaginable. As you relax, let your imagination transport you back to the vibrant world of the Mesozoic. Picture the dense forests where Apatosaurus grazed peacefully, its massive frame swaying with each step. Envision a flock of microraptors darting between trees, their feathers shimmering in the sunlight. Feel the thrill of a Tyrannosaurus rex stalking through the underbrush, its eyes fixed on its next meal. Though their time has passed, the story of the dinosaurs remains a timeless reminder of life's resilience and creativity. The Mesozoic era was a time of staggering biodiversity, its creatures adapting to thrive in environments as varied as dense forests, arid deserts, sprawling savannas, and vast oceans. Each species, from the smallest feathered theropod to the largest sauropod, contributed to the intricate web of life that defined this ancient world. Their existence, documented in fossils and geological formations, continues to provide insights into how life persisted and flourished through millions of years of dynamic change. Imagine a prehistoric landscape dominated by towering cycads and conifers, their branches swaying gently in a humid breeze. Beneath the canopy, a herd of Diplodocus moves deliberately through the underbrush, their long necks dipping and swaying as they strip leaves from the higher branches. These sauropods, despite their massive size, were remarkably efficient grazers, their peg-like teeth adapted for raking vegetation rather than chewing. Their vast stomachs, aided by gastroliths, stones swallowed to help grind plant material, allowed them to process the immense quantities of food required to sustain their enormous bodies. In the same forest, Stegosaurus grazes on low-lying vegetation, its distinctive plates catching the sunlight in hues of earthy reds and oranges. These plates, once thought to serve purely defensive purposes, are now believed to have been used for thermoregulation or display, signaling health or dominance to others of its kind. Fossilized trackways suggest that Stegosaurus may have moved in small groups, offering some measure of protection against predators. Predators like Allosaurus, the apex carnivores of the Jurassic, stalked these herds. With its sharp, serrated teeth and powerful limbs, Allosaurus was a fearsome hunter. However, its fossils also reveal evidence of injuries and infections, hinting at the dangers these creatures faced not only from their prey but also from rivals within their own species. Some fossilized bones show signs of healing, suggesting that even after sustaining significant injuries, these predators could survive and continue to hunt. As the Jurassic transitioned into the Cretaceous, the landscape began to change. The breakup of Pangaea introduced new coastlines, isolated ecosystems, and diverse climates. These changes spurred the evolution of unique species, each adapting to the challenges and opportunities of their environments. In what is now North America, the Western Interior Seaway split the continent, creating vast coastal plains and inland seas teeming with life. Dinosaurs like Tyrannosaurus rex and Triceratops dominated these regions. Tyrannosaurus rex, often depicted as a solitary hunter, may have exhibited more complex social behaviors. Some fossil evidence suggests that T. rex might have hunted in family groups, using their combined strength and strategy to take down large prey. Meanwhile, Triceratops, with its iconic frill and 3 horns, thrived in herds, its physical adaptations offering protection and its social structure ensuring the survival of its young. In South America, the titanic Argentinosaurus roamed the floodplains, its sheer size making it a moving ecosystem. Birds and small mammals likely followed these sauropods, feeding on insects stirred up by their movements or scavenging plant material left behind. The predators of this region, such as Giganotosaurus, evolved to target these giants. With teeth designed for slicing flesh and a lighter, more agile build than Tyrannosaurus rex, Giganotosaurus relied on speed and precision to overcome the immense challenge of bringing down such prey. The skies of the Cretaceous were alive with activity. Pterosaurs, whose evolutionary lineage predates birds, had diversified into a variety of forms. The enormous Quetzalcoatlus, with a wingspan of up to 40 feet, was a master of the air. It likely used thermal currents to glide over vast distances, conserving energy while searching for carrion or small prey. In contrast, smaller pterosaurs like Pterodaustros specialized in filter feeding, their fine, comb-like teeth adapted for sifting tiny organisms from the water. Marine ecosystems during the Mesozoic were equally diverse. In the shallow seas that covered much of the Earth, marine reptiles like Mosasaurus and Plesiosaurus ruled. Mosasaurus, with its powerful tail and streamlined body, was a fast and agile predator, capable of ambushing prey with incredible force. Fossilized remains of Mosasaurus reveal not only its diet but also evidence of violent encounters with other marine reptiles, suggesting a competitive and dangerous existence. The discovery of fossils has transformed our understanding of these ancient creatures, particularly the insights gained from trace fossils such as footprints, nests, and coprolites. Fossilized trackways reveal migration patterns, herd movements, and even the occasional evidence of a stampede, offering a dynamic view of dinosaur behavior. Nests, such as those of Maiasaura, show how some dinosaurs cared for their young, returning to the same nesting sites year after year and protecting their offspring until they were strong enough to survive on their own. Coprolites, or fossilized dung, provide direct evidence of dinosaur diets. Analysis of these ancient droppings has revealed a wealth of information, from the types of plants consumed by herbivores to the bones and scales ingested by carnivores. These fossils offer a unique glimpse into the ecological roles of dinosaurs, highlighting their impact on the environments they inhabited. Feathered dinosaurs bridge the gap between the ancient reptilian world and the modern avian lineage. Discoveries of species like Microraptor and Archaeopteryx have revolutionized our understanding of the evolution of flight. These creatures, with their feathered limbs and tails, were early experiments in aerodynamics, using their adaptations to glide or flutter between trees. Fossil evidence of melanosomes in their feathers has even revealed their colors, painting a picture of a vibrant, dynamic world filled with shimmering, iridescent hues. As the Cretaceous drew to a close, the planet underwent profound changes. Volcanic activity in regions like the Deccan Traps released massive amounts of gases, contributing to climate shifts that stressed ecosystems. Rising sea levels and shifting continents further altered habitats, setting the stage for the catastrophic asteroid impact that would end the reign of the dinosaurs. The asteroid, estimated to be 6 miles wide, struck with unimaginable force, creating the Chicxulub crater and triggering a chain of events that plunged the Earth into darkness. Fires, tsunamis, and a nuclear winter, caused by debris blocking sunlight, devastated ecosystems. Photosynthesis ceased, leading to the collapse of food chains. Within a few years, the age of dinosaurs had ended. Yet, life persisted. Birds, the avian descendants of theropod dinosaurs, adapted to the harsh post-impact world, their small size and varied diets giving them an edge. Mammals, which had coexisted with dinosaurs for millions of years, began to diversify, eventually rising to dominance in the new ecological landscape. Today, the legacy of dinosaurs is all around us. Advances in technology, such as 3D imaging and molecular analysis, continue to reveal new details about their lives, from their diets and growth rates to their vibrant appearances and complex behaviors. Each discovery brings us closer to understanding the incredible diversity and adaptability of these ancient creatures. As you rest, imagine the world of the dinosaurs. A brachiosaurus silhouetted against a dawn sky, its long neck reaching for the canopy. A Quetzalcoatlus soaring high above, its shadow gliding across the ground. A pack of Deinonychus stalking their prey through dense forest undergrowth. Their world, though long gone, echoes in every bird that takes flight, every fossil unearthed, and every question we continue to explore about their incredible history. As the prehistoric Earth transitioned from the dominance of dinosaurs to the rise of mammals, the planet itself underwent transformations that shaped the course of life. The extinction event at the end of the Cretaceous marked not just the end of the age of dinosaurs, but the beginning of new evolutionary opportunities. While the massive asteroid impact created devastation, it also cleared the way for the adaptive radiation of other species, setting the stage for the world we recognize today. The Mesozoic era left behind a remarkable legacy in the form of fossils, ecosystems, and evolutionary innovations that persist in modern life. Birds, as the direct descendants of theropod dinosaurs, are living reminders of this ancient world. From the feathers that enabled flight to their nesting behaviors, birds carry the genetic and behavioral imprint of their dinosaurian ancestors. Every chirp, migration, and intricate mating dance connects us to a time when their ancestors shared the earth with giants. The adaptability of dinosaurs is one of the most striking aspects of their evolutionary success. Over 180 million years, they evolved into forms that ranged from the smallest, chicken-sized Compsognathus to the colossal Argentinosaurus. Their ability to occupy every ecological niche, herbivores grazing on ferns and cycads, carnivores hunting in packs, and omnivores scavenging across the land. Under their extraordinary versatility, dinosaurs didn't just survive. They thrived in environments as varied as polar forests, coastal swamps, arid deserts, and volcanic plains. Fossil evidence from Antarctica reveals that dinosaurs like Cryolophosaurus inhabited polar regions, enduring long winters with limited sunlight. The discovery of dense, fibrous bone structures in these dinosaurs suggests they may have grown rapidly during the warmer months, storing energy to survive harsher conditions. Volcanic activity played a significant role in shaping these prehistoric landscapes. The eruption of the Deccan Traps, which spanned much of what is now India, created vast volcanic plateaus. These eruptions, while destructive, enriched the soil with minerals, fostering lush vegetation that supported herbivorous dinosaurs. Fossils from volcanic regions often preserve exquisite details, as the rapid burial in ash created perfect conditions for fossilization. The oceans of the Mesozoic were no less vibrant. Marine reptiles like Mosasaurus and Ichthyosaurus filled the role of apex predators. Their streamlined bodies and powerful tails adapted for fast, efficient swimming. Fossilized stomach contents of Ichthyosaurus reveal a diet that included fish and squid, while bite marks on the bones of other marine reptiles hint at the ferocity of their interactions. One of the most remarkable adaptations of marine reptiles was their ability to give live birth, a trait revealed by fossils of pregnant individuals. This adaptation eliminated the need to return to land for reproduction, allowing them to become fully aquatic. The discovery of these fossils provides a rare and intimate glimpse into the lives of these ancient creatures. On land, the ecosystems were driven by the constant interplay of predator and prey. The balance between herbivorous dinosaurs and their predators created dynamic relationships that fueled evolutionary innovation. Consider the armored Ankylosaurus, its body covered in bony plates and its tail equipped with a heavy club. This formidable defense forced predators like Tyrannosaurus rex to evolve powerful jaws capable of crushing bone, a trait supported by the fossilized remains of their prey. Herbivores like Iguanodon and Hadrosaurus developed unique adaptations to maximize their efficiency in consuming vegetation. The discovery of complex dental structures in hadrosaurs revealed that they could grind tough plant material with a level of sophistication comparable to modern herbivores. Their social behaviors, evident in fossilized trackways and nesting sites, suggest they traveled in herds, providing protection for the young and ensuring access to abundant food sources. The role of feathers in dinosaur evolution cannot be overstated. What began as simple insulation in small theropods eventually gave rise to structures used for display, camouflage, and flight. Fossils of Microraptor reveal 4 feathered limbs, suggesting an intermediate stage in the evolution of flight. This small dinosaur likely glided between trees, a precursor to the powered flight seen in its avian descendants. Feathered dinosaurs like Sinosauropteryx also provide evidence of complex coloration patterns, including stripes and bands that may have served as camouflage or signaling. The discovery of melanosomes in fossilized feathers has allowed scientists to reconstruct the colors of these ancient creatures, revealing a world far more vibrant than previously imagined. As the Cretaceous period progressed, the Earth's ecosystems grew increasingly complex. Flowering plants began to dominate, supporting a new wave of pollinators, including early insects. This shift in plant life influenced the diets and behaviors of herbivorous dinosaurs, driving further diversification. Fossilized pollen grains and plant material preserved in coprolites provide direct evidence of these interactions, linking the plant and animal kingdoms in a cycle of mutual influence. The end of the Cretaceous brought one of the most dramatic extinction events in Earth's history. The asteroid impact that created the Chicxulub crater unleashed destruction on a scale that reshaped the planet. The immediate aftermath included massive wildfires, tsunamis, and a nuclear winter caused by the debris ejected into the atmosphere. Photosynthesis halted, leading to the collapse of food chains. The dinosaurs, despite their adaptability and resilience, could not survive the rapid environmental changes. Yet, even in this moment of devastation, the seeds of new life were sown. Small mammals, which had lived in the shadow of dinosaurs for millions of years, began to diversify and occupy niches left vacant by the extinction. Birds, the only surviving lineage of dinosaurs, adapted to the new conditions, their ability to fly and forage allowing them to thrive in the post-impact world. The legacy of dinosaurs is evident not only in their avian descendants, but also in the fossilized remains that continue to inspire discovery and innovation. Advances in technology, from isotopic analysis to 3D scanning, have allowed scientists to explore their world in unprecedented detail. These tools have uncovered insights into their growth rates, metabolism, and even their social behaviors, transforming our understanding of these ancient creatures. As you relax and drift further into the world of the Mesozoic, imagine the vivid landscapes these dinosaurs inhabited. Picture the dense forests where Apatosaurus roamed, its long neck weaving through the trees. Visualize a Quetzalcoatlus soaring high above a coastal plain, its shadow gliding silently over the ground. Envision a pack of velociraptors stalking through the underbrush, their feathers rustling as they close in on their prey. These creatures, though long gone, remain etched in the fabric of Earth's history, a reminder of the resilience and creativity of life across the ages. The Mesozoic era, often called the Age of Dinosaurs, was a time of breathtaking evolutionary innovation, ecological diversity, and dramatic planetary changes. As this era unfolded, life on Earth reached heights of complexity and variety that would forever leave an indelible mark on the history of our planet. While the dinosaurs are its most famous inhabitants, the Mesozoic also saw the rise of flowering plants, the dominance of marine reptiles, and the emergence of the first birds. As the late Cretaceous drew to a close, the planet teemed with life across its land, seas, and skies. In the sprawling floodplains of North America, herds of Triceratops moved across the landscape. These ceratopsians, with their massive frills and horns, were among the most iconic dinosaurs of the time. Fossil evidence suggests that Triceratops may have used their horns and frills for a variety of purposes, including defense, mating displays, and intraspecies combat. Healed puncture wounds on their frills hint at clashes with both predators like Tyrannosaurus rex and rivals within their own species. Nearby, the mighty Tyrannosaurus rex prowled the dense forests and open plains. With its bone-crushing bite force and sharp, serrated teeth, T. rex was the apex predator of its ecosystem. However, recent studies have revealed a more nuanced view of this iconic dinosaur. Fossilized remains indicate that T. rex was not solely a predator, but also a scavenger, capable of consuming entire carcasses, bones, and all. This adaptability may have contributed to its success in a competitive and ever-changing environment. Across the globe, other regions were home to equally fascinating dinosaurs. In what is now Mongolia, the deserts and scrublands were populated by species like Velociraptor and Protoceratops. The famous fighting dinosaurs fossil, which captures these two species locked in a deadly struggle, provides a rare and dramatic glimpse into their interactions. This iconic fossil has preserved their story for millions of years, a testament to the ferocity and resilience of life during the Mesozoic. South America was a land of giants, dominated by some of the largest dinosaurs ever discovered. Argentinosaurus, a titanosaur reaching lengths of over 100 feet, moved in herds across the floodplains, feeding on the abundant vegetation. These colossal sauropods, with their long necks and tails, represented the pinnacle of herbivorous dinosaur evolution. Predators like Giganotosaurus and Mapusaurus hunted these massive creatures, their slicing teeth and agile builds enabling them to target the more vulnerable members of sauropod herds. In the skies, pterosaurs maintained their dominance as the first vertebrates to achieve powered flight. Quetzalcoatlus, one of the largest flying animals of all time, soared over vast distances using thermal currents to conserve energy. Its sharp beak and lightweight frame made it an efficient scavenger and hunter. Smaller pterosaurs, like Pterodostro, evolved specialized feeding adaptations, such as filter-feeding teeth, enabling them to exploit aquatic environments. Meanwhile, the oceans were dominated by marine reptiles, which filled roles analogous to modern whales, sharks, and large predatory fish. Mosasaurus, with its powerful tail and sharp teeth, was a top predator in these ancient seas. Fossilized stomach contents reveal that Mosasaurus preyed on fish, ammonites, and even other marine reptiles. In contrast, Plesiosaurus, with its long neck and paddle-like flippers, specialized in hunting smaller prey in shallow waters. One of the most fascinating aspects of the Mesozoic era was the emergence of flowering plants. These angiosperms transformed terrestrial ecosystems, providing new food sources for herbivorous dinosaurs and supporting a diverse array of pollinators. Fossilized plant remains, including pollen grains and leaves, document the rapid expansion of flowering plants during the Cretaceous. Dinosaurs like Iguanodon adapted to this changing flora, their beaks and teeth enabling them to process the tougher vegetation introduced by these plants. The evolution of feathers among theropods represents another major milestone of the Mesozoic. What began as simple insulation in small dinosaurs like Sinosauropteryx evolved into structures used for display, camouflage, and eventually flight. Fossils of feathered dinosaurs such as Microraptor and Archaeopteryx provide critical insights into this transition. These creatures bridged the gap between their terrestrial ancestors and the birds that would follow, their adaptations representing the early stages of powered flight. The fossilized remains of Microraptor, for example, reveal a creature with feathers on all four limbs, allowing it to glide between trees. The discovery of melanosomes in its feathers has even allowed scientists to reconstruct its iridescent coloration, offering a glimpse into the vibrant world of the Mesozoic. Similarly, Archaeopteryx, often considered the first true bird, retained many dinosaurian traits, including teeth, claws, and a long, bony tail. Its ability to fly marked a significant evolutionary leap, paving the way for the avian dominance of the skies. As the Cretaceous period neared its end, the planet was undergoing profound changes. Rising sea levels created new coastal habitats, while volcanic activity in the Deccan Traps released vast amounts of gases, altering the climate. These shifts created a world in flux, setting the stage for the catastrophic asteroid impact that would bring the Mesozoic to a close. The asteroid, striking the Yucatan Peninsula with unimaginable force, triggered a chain of events that reshaped the Earth. Fires, tsunamis, and a nuclear winter caused by debris in the atmosphere devastated ecosystems. Photosynthesis halted, leading to the collapse of food chains. Within a few years, the dinosaurs, along with approximately 75% of all species on Earth, had vanished. Yet, even as the age of dinosaurs ended, their legacy endured. Birds, the descendants of theropod dinosaurs, adapted to the new world, their small size and varied diets allowing them to thrive. Mammals, which had lived in the shadow of dinosaurs for millions of years, began to diversify, taking advantage of the empty niches left by the extinction. Today, the story of dinosaurs continues to captivate scientists and enthusiasts alike. Advances in technology, such as CT scanning and molecular analysis, have transformed paleontology, revealing new details about their biology, behavior, and environments. From their vibrant feathered appearances to their complex social structures, dinosaurs were far more dynamic and diverse than once imagined. As you rest, imagine the vibrant landscapes these creatures once roamed. Picture a herd of Apatosaurus moving slowly through a fern-filled valley, their immense frames swaying as they graze. Envision a flock of microraptors gliding between trees, their iridescent feathers shimmering in the sunlight. Feel the ground tremble as a Tyrannosaurus rex roars, its call echoing through a dense forest. Though their time has passed, the world of dinosaurs remains alive in the fossils they left behind and the birds that carry their legacy into the skies. As the prehistoric world of the Mesozoic unfolded, dinosaurs cemented their role as the undisputed rulers of land, air, and even the fringes of aquatic environments. From the smallest raptors to the towering sauropods, each species played a role in creating ecosystems teeming with life. The story of these incredible creatures is one of constant evolution, driven by environmental shifts, competition, and the unrelenting march of natural selection. In the dense forests of the late Jurassic, life thrived beneath towering cycads and conifers. Among these trees, herds of Stegosaurus grazed, their tails spikes, the famed Thagomizer, poised to fend off any predator bold enough to approach. Fossil evidence suggests that Stegosaurus may have lived in small groups, its iconic plates serving not only as potential thermoregulatory devices, but also as visual displays for communication within the herd or to intimidate rivals. In the same region, predators like Allosaurus hunted with ruthless efficiency. With powerful jaws and sharp, serrated teeth, Allosaurus was built for ambush attacks, targeting the softer, more vulnerable parts of its prey. Studies of its skull suggest a unique adaptation. The ability to pivot its upper jaw independently of its lower, delivering slashing bites that inflicted severe damage. Fossilized bones of sauropods often bear the telltale marks of Allosaurus teeth, evidence of the deadly encounters that defined life in these ancient landscapes. Moving into the Cretaceous period, the Earth's environments became even more diverse as continental drift continued to reshape the planet. In North America, the western interior seaway divided the continent, creating coastal plains and inland waterways that supported a unique array of dinosaur species. Along these shores, Tyrannosaurus rex reigned as the apex predator. Its immense skull and robust teeth, capable of crushing bone, made it an unparalleled hunter and scavenger. Recent studies have revealed the presence of sensory pits in its snout, suggesting that T. rex had a highly developed sense of touch, which may have helped it locate prey or manipulate objects. In these same ecosystems, herds of Edmontosaurus, a type of hadrosaur, moved in organized groups. Their flattened, duck-billed mouths were perfectly suited for cropping vegetation, while their rows of grinding teeth enabled them to process tough plant material. Fossilized trackways indicate that these herbivores traveled in large herds, providing safety in numbers against predators. Their social behaviors, inferred from nesting sites and fossilized remains, highlight the complex dynamics of herbivorous dinosaur communities. Farther south, in the lush forests of South America, the gigantic Argentinosaurus roamed. This titanosaur, one of the largest land animals to ever exist, represents the pinnacle of sauropod evolution. Fossilized remains suggest that Argentinosaurus could grow to lengths of over 100 feet, its massive frame supported by a unique system of air-filled bones that reduced weight without compromising strength. The predators of this region, such as Giganotosaurus, evolved to challenge these giants. With slicing teeth and an agile build, Giganotosaurus likely targeted younger or weaker members of sauropod herds, relying on strategy and persistence to overcome their immense prey. In Asia, the deserts of the late Cretaceous were home to a different kind of predator-prey dynamic. Velociraptor, a small but highly intelligent theropod, hunted in the arid regions of what is now Mongolia. Its sharp claws and keen eyesight made it a formidable predator, while its feathers, revealed through fossil evidence, suggest it may have used them for display or thermoregulation. Fossils of Protoceratops, a common herbivore in the same region, are often found in proximity to velociraptor remains, highlighting the predator-prey relationship that defined their interactions. The skies of the Cretaceous were dominated by pterosaurs, whose mastery of flight enabled them to exploit ecological niches inaccessible to terrestrial dinosaurs. Quetzalcoatlus, with its enormous wingspan, soared effortlessly over vast distances, using thermal currents to conserve energy. Its sharp beak and hollow bones made it an efficient scavenger and hunter. Smaller pterosaurs, like Pterodostro, specialized in feeding on tiny aquatic organisms, their fine, comb-like teeth filtering food from the water. The oceans of the Mesozoic were no less spectacular. Marine reptiles like Mosasaurus and Ichthyosaurus ruled these ancient seas. Mosasaurus, a fearsome predator with a streamlined body and powerful tail, was built for speed and power. Fossilized stomach contents reveal a diet that included fish, ammonites, and even other marine reptiles, underscoring its role as an apex predator. In contrast, Ichthyosaurus, with its dolphin-like body, was a fast and agile swimmer, adapted for hunting smaller, more elusive prey in open waters. Feathered dinosaurs bridged the gap between traditional theropods and modern birds. Microraptor, a small, four-winged dinosaur, is a prime example of this evolutionary transition. Its feathers, which covered its limbs and tail, allowed it to glide between trees, evading predators and catching prey. The discovery of melanosomes in fossilized feathers has even revealed its coloration, showing that Microraptor had iridescent plumage, similar to modern crows. The evolution of feathers in dinosaurs like Anchiornis and Archaeopteryx highlights the gradual development of flight. These early avian ancestors retained many dinosaurian traits, such as teeth and clawed wings, but their adaptations for powered flight set them apart. Fossil evidence of their bones and feathers provides critical insights into how modern birds inherited and refined these traits. Sauropods like Argentinosaurus and Dreadnoughtus were the titans of these ecosystems, their immense size deterring most predators. These dinosaurs reached lengths of over 100 feet and weights of up to 70 tons, their bodies supported by a unique skeletal structure that included air-filled bones to reduce weight. Their long necks allowed them to feed on vegetation high above the ground, giving them access to food sources unavailable to other herbivores. Fossilized trackways of sauropods often reveal evidence of herding behavior, suggesting that these giants moved together for mutual protection. In Asia, the deserts and forests of the late Cretaceous were home to an entirely different array of creatures. The small but deadly velociraptor hunted in packs, using its sharp claws and keen intelligence to take down prey. Fossilized impressions reveal that Velociraptor was feathered, a discovery that has revolutionized our understanding of these dinosaurs. Their feathers, likely used for display and insulation, hint at a lineage closely tied to modern birds. The fossilized remains of Protoceratops, a common herbivore in the same region, provide additional insights into predator-prey dynamics. One famous fossil captures a velociraptor and a Protoceratops locked in combat, their struggle preserved in stone for millions of years. This extraordinary find offers a glimpse into the interactions that defined these ancient ecosystems, showcasing the balance of survival that each creature sought to maintain. Above the land, the skies were dominated by pterosaurs, whose mastery of flight allowed them to exploit ecological niches unavailable to their terrestrial counterparts. Quetzalcoatlus, one of the largest flying animals to ever exist, soared over ancient coastlines, using its long beak to scavenge or hunt small prey. Smaller pterosaurs, like Rhamphorhynchus, specialized in different niches, their sharp teeth and aerodynamic bodies adapted for catching fish on the wing. In the oceans, marine reptiles like Mosasaurus and Kronosaurus reigned supreme. These apex predators were built for dominance, their streamlined bodies and powerful tails enabling them to pursue prey with speed and precision. Fossilized remains of Mosasaurus reveal evidence of fierce competition, including bite marks and injuries likely inflicted during territorial disputes or mating battles. Meanwhile, Plesiosaurus, with its long neck and paddle-like limbs, specialized in hunting smaller prey in shallow waters. The fossilized stomach contents of marine reptiles provide direct evidence of their diets, revealing a world of predation and survival beneath the waves. As the Cretaceous period neared its end, flowering plants began to dominate terrestrial ecosystems, transforming the planet's flora. These plants supported a diverse array of pollinators, including early insects, which in turn influenced the diets and behaviors of herbivorous dinosaurs. Fossilized coprolites provide valuable insights into these interactions, preserving traces of plant material that reveal the dietary habits of these ancient creatures. The asteroid impact that ended the Cretaceous brought this vibrant world to an abrupt halt. The Chicxulub impact unleashed a series of catastrophic events, including wildfires, tsunamis, and a nuclear winter caused by the ejection of debris into the atmosphere. Photosynthesis ceased, leading to the collapse of food chains and the extinction of approximately 75% of all species on Earth. Yet, amidst this devastation, life persisted. Birds, the avian descendants of theropod dinosaurs, adapted to the harsh post-impact environment, their small size and diverse diets giving them a survival advantage. Mammals, which had coexisted with dinosaurs for millions of years, began to diversify, filling the ecological niches left vacant by the extinction. Today, the legacy of dinosaurs endures in the fossils they left behind and the birds that continue to soar across our skies. Advances in technology, from CT scanning to molecular analysis, have transformed paleontology, uncovering new details about the biology, behavior, and environments of these ancient creatures. From their vibrant feathered plumage to their complex social structures, dinosaurs were far more dynamic and diverse than once imagined. As you rest, let your imagination wander through their world. Picture a herd of triceratops grazing in the golden light of a prehistoric dawn, their horns casting long shadows. Envision a Quetzalcoatlus gliding effortlessly over a coastal plain, its wings stretched wide against the horizon. Feel the ground tremble as a Tyrannosaurus rex stalks through a dense forest, its sharp eyes scanning for movement. Though their time has passed, their story remains a testament to the resilience and creativity of life on Earth, an enduring source of wonder and inspiration. The world of the Mesozoic was a tapestry of interconnected ecosystems, each filled with creatures that showcased evolution's boundless creativity. Dinosaurs, pterosaurs, marine reptiles, and early mammals formed a living network of competition, cooperation, and survival. As the Triassic gave way to the Jurassic and eventually the Cretaceous, these ecosystems adapted to continental drift, climate changes, and the emergence of new species, creating a dynamic and ever-changing planet. On the vast floodplains of late Cretaceous North America, Edmontosaurus herds moved en masse, their numbers offering protection from the apex predators that lurked nearby. These duck-billed dinosaurs, or hadrosaurs, were masters of survival. Their dental batteries, composed of hundreds of tightly packed teeth, allowed them to process the tough vegetation of their environment efficiently. Fossil evidence of nesting sites indicates that they return to the same locations year after year, laying eggs and nurturing their young in communal nesting grounds. This behavior underscores the advanced social structures that some herbivorous dinosaurs developed to ensure their survival in a predatory world. Nearby, Tyrannosaurus rex reigned as the apex predator. With a bite force capable of crushing bone, it had evolved to consume not only the flesh of its prey, but also the nutrient-rich marrow within. Fossilized bones of prey species often bear distinctive bite marks, evidence of the powerful jaws and serrated teeth of this iconic dinosaur. Yet, T. rex was not just a hunter, it was an opportunist. Its acute sense of smell allowed it to locate carcasses from great distances, and its massive size ensured that few creatures could challenge it for a meal. Fossilized trackways and biomechanical studies of its skeletal structure suggest that despite its size, T. rex could move with surprising speed over short distances, making it a formidable predator and scavenger. In South America, the immense sauropods like Argentinosaurus dominated the landscape. These titans moved in herds across open floodplains, their long necks allowing them to browse on the treetops while their massive tails balanced their colossal frames. Their size made them nearly invulnerable to predators, but fossil evidence suggests that young sauropods were not so fortunate. The theropods of the region, such as Giganotosaurus and Mapusaurus, likely targeted juveniles or sick individuals, employing pack-hunting strategies to take down prey far larger than themselves. The discovery of theropod bone beds, containing remains of multiple individuals of the same species, supports the hypothesis that these predators lived and hunted in groups. Asia's Cretaceous ecosystems offered a different but equally vibrant array of life. The deserts of what is now Mongolia were home to Velociraptor and its prey, including Protoceratops. Fossilized remains capturing the famous struggle between these two dinosaurs. A Velociraptor locked in combat with a Protoceratops provide an unparalleled glimpse into the predator-prey dynamics of the time. These fossils reveal not just the physical characteristics of these creatures, but also their behaviors, preserved in a moment of life-and-death struggle that spanned millions of years. The fossil record from Asia also highlights the evolutionary transition from dinosaurs to birds. Species like Microraptor and Anchiornis blur the lines between these two groups, their feathered bodies and adaptations for gliding or flight showcasing the gradual development of avian traits. Microraptor, with feathers on all four limbs, likely glided between trees and dense forests, its iridescent plumage serving both as camouflage and a display to attract mates or deter rivals. The discovery of melanosomes in these fossils has allowed scientists to reconstruct their colors, adding a vivid dimension to our understanding of these ancient creatures. In the skies above, pterosaurs continued to evolve, diversifying into forms that ranged from the massive Quetzalcoatlus to the smaller, filter-feeding Pterodaustro. Quetzalcoatlus, with its towering height and long beak, likely scavenged along coastlines, its massive wings enabling it to travel vast distances in search of food. Its smaller relatives filled niches closer to the ground, feeding on fish, insects, and other small prey. The discovery of pterosaur nesting sites, complete with fossilized eggs, reveals that these creatures may have cared for their young, returning to the same locations to breed season after season. In the oceans, marine reptiles like Mosasaurus and Plesiosaurus dominated the aquatic ecosystems. Mosasaurus, a top predator, was equipped with powerful jaws and sharp, conical teeth, making it a fearsome hunter of fish, ammonites, and other marine reptiles. Fossilized remains often show evidence of intraspecies conflict, including bite marks and broken bones, suggesting that these apex predators competed fiercely for territory and resources. In contrast, Plesiosaurus specialized in shallow coastal waters, its long neck and paddle-like flippers perfectly adapted for catching smaller, faster prey. The diversity of marine reptiles highlights the complexity of Mesozoic oceanic ecosystems, where each species carved out a unique niche. The evolution of flowering plants during the Cretaceous had a profound impact on terrestrial ecosystems. These angiosperms provided new food sources for herbivorous dinosaurs and supported a burgeoning population of pollinators, including early insects. Fossilized coprolites, fossilized dung, reveal traces of flowering plants in the diets of dinosaurs like Iguanodon, demonstrating the interconnectedness of these ancient ecosystems. The spread of flowering plants also contributed to the diversification of herbivores, as dinosaurs adapted to exploit this new resource. As the Mesozoic era drew to a close, the Earth faced a series of dramatic events that would alter the course of life forever. The asteroid impact that created the Chicxulub crater triggered massive wildfires, tsunamis, and a prolonged nuclear winter caused by the ejection of debris into the atmosphere. These events led to the collapse of food chains, marking the end of the age of dinosaurs. Yet, even in the face of such devastation, life persisted. Birds, the direct descendants of theropod dinosaurs, survived and thrived, their ability to adapt and innovate allowing them to flourish in the New World. Small mammals, which had coexisted with dinosaurs for millions of years, began to diversify, filling the ecological niches left vacant by the extinction. Today, The story of the Mesozoic lives on in the fossils unearthed from ancient rock formations and the birds that soar across our skies. Advances in paleontology, from high-resolution imaging to molecular studies, continue to uncover new details about the biology, behavior, and evolution of these ancient creatures. Each discovery adds a new chapter to the story, reminding us of the incredible resilience and adaptability of life on Earth. As you drift into the quiet of relaxation, let your imagination wander through the vibrant landscapes of the Mesozoic. Picture a herd of Apatosaurus moving slowly across a sunlit valley, their immense frames swaying in unison. Envision a flock of feathered microraptors darting between the trees, their iridescent plumage shimmering in the dappled light. Feel the rumble of a Tyrannosaurus rex as it strides through a forest, its powerful tail sweeping the ground behind it. Though their time has passed, the legacy of the dinosaurs lives on, a testament to the beauty and creativity of life's evolutionary journey. The Mesozoic era remains one of the most extraordinary periods in Earth's history, characterized by immense biological diversity, dramatic environmental changes, and evolutionary innovations that shaped the planet's future. While dinosaurs dominated the land, their story is only part of a much larger narrative. From the skies filled with pterosaurs to the oceans teeming with marine reptiles and the emergence of flowering plants, every corner of the Mesozoic world was alive with activity, each species playing a role in an intricate ecological web. As the Triassic period transitioned into the Jurassic, the world was still recovering from the Permian-Triassic extinction, which had wiped out the majority of Earth species. This time of recovery allowed new forms of life to emerge and diversify. Early dinosaurs were relatively small, nimble creatures, but they quickly evolved into a wide array of sizes and shapes. The first sauropodomorphs, like Plateosaurus, began to explore the advantages of large size, setting the stage for the massive sauropods of the Jurassic and Cretaceous. By the late Jurassic, the Earth was dominated by lush forests and expansive floodplains, home to some of the largest animals to ever walk the planet. Brachiosaurus, with its long neck and massive limbs, towered over the landscape, feeding on the treetops that other herbivores could not reach. Its anatomy was a marvel of engineering, with air sacs in its vertebrae reducing weight and a unique circulatory system likely aiding in pumping blood to its elevated head. Fossil evidence suggests that Brachiosaurus may have traveled in small groups, their size offering protection against predators like Allosaurus. Allosaurus was the apex predator of its time. Its robust skull and sharp teeth adapted for delivering powerful bites. However, fossilized remains show evidence of injuries and infections, suggesting that life was as perilous for predators as it was for prey. Bite marks on the bones of sauropods indicate that Allosaurus likely targeted juveniles or sick individuals, using ambush tactics to overcome its massive prey. Meanwhile, smaller herbivores like Stegosaurus played a crucial role in the ecosystem. Stegosaurus used its spiked tail, or thagomizer, as a defense against predators, while its plates may have been used for thermoregulation or display. Fossilized trackways indicate that Stegosaurus may have moved in small groups, their collective presence deterring predators from attacking. As the Jurassic gave way to the Cretaceous, the planet's geography continued to change. The breakup of Pangaea created new coastlines and isolated landmasses, driving the evolution of species adapted to specific environments. In North America, the Western Interior Seaway split the continent, creating coastal ecosystems that supported a unique array of life. Dinosaurs like Tyrannosaurus rex and Triceratops thrived in these regions, their fossils offering a glimpse into the dynamic interactions between predator and prey. Triceratops is one of the most iconic dinosaurs of the late Cretaceous, its massive frill and 3 horns making it a formidable opponent for predators. Fossil evidence suggests that these features were used not only for defense, but also for mating displays and intraspecies competition. Healed injuries on their frills indicate that these dinosaurs engaged in combat, locking horns with rivals in displays of dominance. Tyrannosaurus rex, often considered the king of dinosaurs, was a predator perfectly adapted to its environment. With its massive skull, strong neck muscles, and bone-crushing bite force, it could take down large prey or scavenge carcasses with equal efficiency. Recent studies of its olfactory bulbs suggest that T. Rex had an exceptional sense of smell, enabling it to locate prey or carrion from great distances. Fossilized trackways show that despite its size, T. rex was capable of surprising speed over short distances, making it a deadly ambush predator. In South America, the enormous Argentinosaurus roamed the floodplains, its massive size protecting it from most predators. However, theropods like Giganotosaurus posed a significant threat. These predators, slightly larger than T. rex, had sharp, slicing teeth and a more slender build, allowing them to move quickly and efficiently. Fossil evidence suggests that Giganotosaurus may have hunted in packs, a behavior that would have increased its ability to target massive sauropods. In Asia, the deserts of what is now Mongolia were home to Velociraptor and Protoceratops. The fossilized remains of these dinosaurs often reveal dramatic interactions, such as the famous fighting dinosaurs fossil that captures a velociraptor locked in combat with a Protoceratops. This extraordinary find provides a snapshot of their predator-prey dynamics, preserved in stone for millions of years. The skies of the Cretaceous were filled with the soaring forms of pterosaurs. Quetzalcoatlus, one of the largest flying animals of all time, used its massive wingspan to glide effortlessly over great distances, likely scavenging for food or hunting small prey. Smaller pterosaurs like Pterodostro specialized in specific niches, such as filter feeding, their fine teeth adapted for sifting plankton from the water. In the oceans, marine reptiles like Mosasaurus and Plesiosaurus dominated. Mosasaurus, with its streamlined body and powerful tail, was the apex predator of the seas, preying on fish, ammonites, and even other marine reptiles. Fossil evidence of bite marks and healed injuries suggests that these creatures often engaged in territorial disputes or battles over resources. Plesiosaurus, on the other hand, was adapted for hunting in shallow coastal waters, its long neck and paddle-like limbs allowing it to catch smaller prey with precision. The evolution of feathers among theropods was one of the most significant developments of the Mesozoic. Species like Microraptor and Archaeopteryx demonstrate the gradual transition from terrestrial dinosaurs to avian forms. Microraptor, with feathers on all four limbs, was capable of gliding between trees, while Archaeopteryx, often considered the first true bird, achieved powered flight. The discovery of melanosomes in these fossils has allowed scientists to reconstruct their coloration, revealing a world filled with vibrant, iridescent feathers. The end of the Cretaceous was marked by one of the most catastrophic events in Earth's history. The asteroid impact that created the Chicxulub crater triggered fires, tsunamis, and a prolonged nuclear winter. The resulting collapse of ecosystems led to the extinction of approximately 75% of all species, including all non-avian dinosaurs. Yet, even in the face of such devastation, life persisted. Birds, the avian descendants of theropod dinosaurs, adapted to the new world, while mammals began to diversify, eventually rising to dominance in the Cenozoic era. As you drift deeper into relaxation, let your imagination transport you to the vibrant world of the Mesozoic. Picture a stegosaurus grazing peacefully in a fern-filled valley, its plates catching the morning sunlight. Envision a flock of feathered microraptors gliding between trees, their iridescent feathers shimmering in the dappled light. Feel the ground tremble as a herd of Diplodocus moves across the plains, their long necks swaying in unison. The world of dinosaurs may be gone, but its story continues to inspire wonder and curiosity, reminding us of the resilience and creativity of life on Earth. The prehistoric landscapes of the Mesozoic era were more than just backdrops. They were dynamic systems that influenced and were influenced by the creatures inhabiting them. From volcanic eruptions shaping new terrains to the gradual formation of mountain ranges, these environmental changes spurred evolutionary adaptations that gave rise to some of the most iconic dinosaurs. Volcanoes played a significant role in the Mesozoic world. Eruptions not only reshaped the land, but also released gases and minerals that altered the atmosphere and enriched the soil. These fertile grounds supported lush vegetation, which in turn provided sustenance for herbivorous dinosaurs like Iguanodon and Diplodocus. However, volcanic activity also brought challenges. Ash clouds from eruptions could darken the skies, leading to short-term cooling and disruptions in food supplies. Evidence of volcanic layers in fossil-rich areas reveals the impact of these events, preserving a snapshot of life abruptly halted and later fossilized. As the continents shifted due to tectonic activity, new ecosystems emerged. The breakup of Pangaea created coastlines, mountain ranges, and inland seas that fostered regional diversification. In North America, the Western Interior Seaway split the continent, creating an aquatic corridor that hosted marine reptiles like Mosasaurus and Plesiosaurus. Along the seaway's shores, dinosaurs such as Tyrannosaurus rex and Triceratops thrived, adapting to the abundant resources these transitional environments provided. In Asia, the deserts and forests of the late Cretaceous were home to dinosaurs like Velociraptor and Protoceratops. Fossils of these creatures, often found in the Gobi Desert, paint a vivid picture of predator-prey dynamics. The famous fighting dinosaurs fossil, which captures a Velociraptor and Protoceratops locked in combat, offers a rare and dramatic glimpse into their interactions. This snapshot of a prehistoric struggle provides invaluable insights into their behaviors and physical capabilities. The climates of the Mesozoic were as varied as the landscapes. The Triassic began with hot, arid conditions, favoring early reptiles like Coelophysis. As the Jurassic unfolded, the planet became warmer and more humid, supporting vast forests and the rise of the sauropods. By the Cretaceous, climates were more diverse, with polar regions experiencing seasons of darkness and warmth. Fossil evidence from these areas, such as Cryolophosaurus in Antarctica, demonstrates the adaptability of dinosaurs to extreme environments. The interplay between dinosaurs and their environments extended to their diets and behaviors. Herbivorous dinosaurs like Stegosaurus and Ankylosaurus shaped their ecosystems by consuming large amounts of vegetation, creating clearings that allowed sunlight to reach the forest floor. This, in turn, fostered the growth of new plants, maintaining the cycle of life. Fossilized stomach contents and coprolites reveal the dietary preferences of these creatures, offering a direct window into their ecological roles. Predators like Allosaurus and Spinosaurus were equally integral to their ecosystems. Their hunting activities regulated herbivore populations, preventing overgrazing and promoting ecological balance. The physical adaptations of these predators, from the serrated teeth of Allosaurus to the elongated snout of Spinosaurus, highlight their specialization for different types of prey. These adaptations were products of millions of years of evolution, driven by the demands of their environments and the competition within them. Feathers, one of the most significant evolutionary developments of the Mesozoic, also played a critical role in the lives of many dinosaurs. Initially evolving for insulation, feathers later became tools for communication, camouflage, and, eventually, flight. The discovery of feathered dinosaurs like Microraptor and Anchiornis has transformed our understanding of dinosaur behavior and appearance. These creatures, with their intricate plumage, inhabited forests where their feathers provided both thermoregulation and visual signaling. The study of fossilized feathers has even revealed their coloration. Analysis of melanosomes, the pigment-containing structures in feathers, shows that Microraptor likely had an iridescent sheen, similar to modern crows. This discovery adds a vivid dimension to our perception of these ancient creatures, illustrating a world filled with vibrant colors and dynamic interactions. As dinosaurs diversified, so too did their strategies for survival and reproduction. The discovery of nesting sites, such as those of Maiasaura, offers compelling evidence of parental care. These good mother lizards constructed nests, arranged their eggs carefully, and likely tended to their young after hatching. This behavior suggests a level of social complexity that parallels that of modern birds. Other dinosaurs adopted different reproductive strategies. Protoceratops laid its eggs in shallow scrapes in the ground, relying on the environment to incubate them. Fossilized eggs and embryos reveal the development of these dinosaurs before hatching, providing a glimpse into their earliest stages of life. These discoveries underscore the diversity of approaches dinosaurs used to ensure the survival of their species. The late Cretaceous was a period of immense change, setting the stage for the dramatic events that would end the age of dinosaurs. The asteroid impact, which struck the Yucatan Peninsula approximately 66 million years ago, unleashed a chain of catastrophic events. The force of the collision created shockwaves, tsunamis, and a global cloud of debris that blocked sunlight for months. This impact winter led to a rapid decline in temperatures and the collapse of food chains. Despite the devastation, life persisted. Small mammals, reptiles, and birds survived the harsh conditions, their adaptability and diverse diets giving them an edge. These survivors would go on to dominate the planet in the aftermath of the extinction event, leading to the rise of mammals and the eventual emergence of humans. Today, the legacy of dinosaurs is all around us. Birds, their avian descendants, continue to thrive, their behaviors and anatomy providing direct links to their prehistoric ancestors. Every time we hear the call of a bird or watch it take flight, we witness the enduring impact of the Mesozoic. The fossils left behind by dinosaurs are windows into a world long past, each discovery adding to our understanding of their lives. Advances in technology, such as CT scanning and isotopic analysis, allow scientists to reconstruct their appearances, diets, and even their movements with remarkable precision. These tools have transformed paleontology, turning fossils from static relics into dynamic stories of life on ancient Earth. As you rest, let your imagination wander through these ancient landscapes. Picture the dense forests where Brachiosaurus grazed peacefully, its long neck weaving through the canopy. Envision the shimmering waters of a prehistoric sea, where Ichthyosaurus darted gracefully in pursuit of fish. Feel the ground tremble as a herd of Triceratops moves across the plains, their horns and frills gleaming in the sunlight. The world of dinosaurs may be gone, but its echoes remain, inspiring wonder and curiosity across the ages. The age of dinosaurs, spanning over 180 million years, represents one of the most extraordinary chapters in Earth's history. This period, divided into the Triassic, Jurassic, and Cretaceous periods, saw the rise and fall of some of the most magnificent creatures to ever walk, swim, or fly on this planet. The interplay of their evolution, behavior, and environmental adaptation created ecosystems that were as dynamic and intricate as anything seen today. In the early days of the Triassic, life was recovering from the Permian-Triassic extinction event, the most devastating mass extinction in Earth's history. Over 90% of species had been wiped out, leaving a barren world ripe for new life to emerge. Among the survivors were small reptiles and amphibians, which began to diversify and fill ecological niches left vacant by the extinction. This era laid the groundwork for the eventual rise of the dinosaurs. Early dinosaurs, such as Herosaurus and Eoraptor, were relatively small compared to their later relatives. These creatures were bipedal, swift, and agile, relying on speed to evade predators and hunt for prey. Their ability to adapt to a wide range of environments allowed them to gradually outcompete other reptiles, becoming dominant terrestrial vertebrates by the late Triassic. As the Jurassic dawned, the planet underwent significant climatic and geographical changes. The breakup of Pangaea created new coastlines and inland seas, while a warmer, more humid climate fostered the growth of extensive forests. This lush environment supported an explosion of biodiversity, including the rise of the sauropods, the largest animals to ever walk the Earth. Sauropods like Brachiosaurus and Diplodocus were marvels of evolutionary engineering. Their immense size served as both a deterrent to predators and a strategy for reaching food sources inaccessible to smaller herbivores. Fossil evidence of their vertebrae, hollowed out with air sacs, reveals how these giants managed to support their massive frames. Their long necks allowed them to graze over wide areas without moving their bodies, conserving energy in environments where food could be sparse. The Jurassic period also saw the emergence of iconic predators like Allosaurus and Ceratosaurus. These theropods were apex predators, using their sharp teeth and claws to hunt herbivores. Fossilized bones of their prey often show evidence of bite marks, providing direct evidence of their hunting techniques. Trackways suggest that some theropods may have hunted in groups, working together to take down larger prey. As the Jurassic transitioned into the Cretaceous, the evolutionary landscape shifted once again. The breakup of Pangaea continued, isolating populations and driving speciation. The Cretaceous period is notable for the rise of flowering plants, which introduced new ecological dynamics. Dinosaurs like Iguanodon and Edmontosaurus adapted to these changes, developing sophisticated dental structures for processing tough vegetation. Hadrosaurs, or duck-billed dinosaurs, were among the most successful herbivores of the late Cretaceous. Their flattened snouts and rows of tightly packed teeth made them efficient grazers. Fossilized trackways show evidence of herding behavior, suggesting that these dinosaurs traveled in large groups for protection and access to food. Some species, like Parasaurolophus, featured elaborate crests that may have been used for communication or display. The predator-prey dynamics of the Cretaceous were equally fascinating. Tyrannosaurus rex, with its massive skull and bone-crushing bite force, dominated the ecosystems of North America. Its physical adaptations made it a formidable hunter, but it also likely scavenged when opportunities arose. Meanwhile, in South America, Giganotosaurus and Mapusaurus filled similar roles, hunting the enormous sauropods that roamed the continent. Dinosaurs weren't the only creatures to thrive during the Mesozoic. Marine reptiles like Mosasaurus and Plesiosaurus ruled the seas, while flying reptiles like Pteranodon dominated the skies. These creatures, while not dinosaurs, shared their world and contributed to its rich biodiversity. Fossilized remains of marine reptiles often reveal stomach contents, providing direct evidence of their diets and predatory habits. The fossil record also reveals surprising details about the behavior and biology of dinosaurs. The discovery of nesting sites, such as those of Maiasaura, offers a glimpse into their reproductive strategies. These good mother lizards constructed nests, carefully arranged their eggs, and likely cared for their young after hatching. Fossilized embryos provide further insights, showing the development of dinosaurs before birth and suggesting that some species may have been precocial, capable of moving and feeding shortly after hatching. The evolution of feathers among theropods is another remarkable aspect of dinosaur biology. Initially thought to serve as insulation, feathers later became tools for display and, eventually, flight. Fossils of feathered dinosaurs like Microraptor and Anchiornis highlight the diversity of these structures, from simple down-like coverings to complex flight feathers. Analysis of melanosomes in fossilized feathers has even revealed their colors, showing that some dinosaurs had vibrant, iridescent plumage. As the Cretaceous period came to an end, the stage was set for one of the most dramatic events in Earth's history, the Cretaceous-Paleogene extinction event. The asteroid impact that struck the Yucatan Peninsula 66 million years ago unleashed a chain reaction of environmental catastrophes. The initial impact vaporized rock, sending shockwaves across the planet. This was followed by massive tsunamis, wildfires, and a global cloud of debris that blocked sunlight for months, plunging the Earth into a nuclear winter. The consequences of this event were devastating. Without sunlight, photosynthesis ceased, leading to the collapse of food chains. Herbivorous dinosaurs starved, and the predators that depended on them soon followed. Within a few years, the age of dinosaurs had come to an end, leaving only their avian descendants to carry their legacy into the modern world. Today, the study of dinosaurs continues to evolve, with new discoveries challenging long-held assumptions and revealing previously unknown details about their lives. From the vibrant colors of their feathers to the intricacies of their social behaviors, dinosaurs were far more dynamic and complex than once imagined. Advances in technology, such as CT scanning and isotopic analysis, have allowed scientists to reconstruct their appearances, movements, and even their diets with remarkable precision. As you drift into a deeper state of relaxation, imagine the vibrant world of the Mesozoic. Picture the forests where Apatosaurus grazed peacefully, its massive frame swaying as it moved through the underbrush. Envision a flock of Microraptors gliding between trees, their iridescent feathers shimmering in the sunlight. Feel the ground tremble as a herd of Triceratops moves across an open plain, their horns and frills gleaming in the warm glow of the Cretaceous sun. The world of dinosaurs may be gone, but its echoes remain, inspiring wonder and curiosity across the ages. As the dust settled from the asteroid impact that marked the end of the Cretaceous period, the Earth entered a new chapter in its history. The age of dinosaurs had come to a dramatic close, yet their legacy persisted, carried forward by the avian dinosaurs that survived and the profound ecological changes their extinction set in motion. The evolutionary story of these remarkable creatures continues to unfold, not only through the fossils they left behind, but also through the traits inherited by modern birds and the ecosystems shaped by their ancient predecessors. The fossil record, a window into the past, reveals the astonishing diversity and complexity of dinosaur life. From their earliest origins in the Triassic to their dominance in the Jurassic and Cretaceous, dinosaurs adapted to a staggering array of environments. Each fossil, whether a bone, a tooth, or a feather, tells a story of survival, competition, and innovation. These ancient relics are more than just remnants of the past. They are clues to the processes that have shaped life on Earth. Imagine the vibrant ecosystems of the late Cretaceous, where dinosaurs of all shapes and sizes roamed the planet. In the dense forests of what is now North America, the mighty Tyrannosaurus rex prowled the underbrush, its powerful legs carrying it with surprising speed. Despite its size and reputation as a predator, T. rex was likely an opportunistic feeder, scavenging when the opportunity arose. Its keen sense of smell, indicated by the large olfactory bulbs in its skull, made it adept at detecting carcasses from miles away. Meanwhile, herbivorous dinosaurs like Triceratops grazed on low-lying vegetation, their formidable horns and frills serving both as defense mechanisms and as tools for social interaction. Fossil evidence of healed injuries on their frills suggests that these dinosaurs engaged in head-to-head combat, possibly over mates or territory. Their herding behavior, inferred from fossilized trackways, provided safety in numbers, reducing the risk of predation. In the open plains of South America, the enormous Argentinosaurus lumbered across the landscape, its immense size deterring even the most determined predators. This titanosaur, one of the largest dinosaurs ever discovered, could reach lengths of over 100 feet, its neck allowing it to browse on vegetation high above the ground. Fossilized footprints of Argentinosaurus reveal the sheer scale of these creatures, each step leaving an impression large enough to stand in. Predators like Giganotosaurus and Mapusaurus shared these environments, their massive jaws and slicing teeth adapted for hunting large prey. Fossilized remains of sauropods bearing bite marks from these predators suggest that they targeted juvenile or weakened individuals, using their speed and teamwork to overwhelm their prey. This strategy highlights the dynamic interplay between predator and prey, driving evolutionary adaptations on both sides. The marine environments of the Mesozoic were equally dynamic. In the shallow seas that covered much of the planet, marine reptiles like Mosasaurus and Elasmosaurus dominated. Mosasaurus, with its elongated body and powerful tail, was a top predator, capable of taking down prey as large as other marine reptiles. Fossils of Mosasaurus often reveal stomach contents that include fish, squid, and even smaller marine reptiles, providing direct evidence of its diet. In contrast, the long-necked Elasmosaurus was a specialist, using its flexible neck to dart its head into schools of fish. Its streamlined body and paddle-like limbs allowed it to move gracefully through the water, conserving energy while hunting. These marine reptiles, though not dinosaurs, were integral to the ecosystems of the Mesozoic, shaping the dynamics of life beneath the waves. The skies above were dominated by pterosaurs, whose mastery of flight enabled them to exploit niches inaccessible to terrestrial and marine creatures. Pteranodon, with its long, pointed beak, soared above coastlines, feeding on fish and other small prey. Its lightweight skeleton and large wings made it an efficient glider, capable of traveling long distances with minimal effort. Smaller pterosaurs, like Pterodostro, used specialized teeth to filter feed in shallow waters, demonstrating the incredible diversity of these flying reptiles.